Hi guys, it's Jet Skeptic Media here. This is such an exciting day. I swear we're going to see the Flat Earthers' first model. I heard Flat Earth British talking about it on a hangout with Doomweaver. This is going to be history in the making. I can't wait. This is so exciting. Globebusters have their first map, working map. This is going to blow all the skepticism away. Even me. I might even change my name to Jed Flat Earth Media. My heart's beating here. I can't wait. Let's go, guys. Let's watch this.
Oh, you heard that right. Join Awake Souls, Jason Laufenberg, and Ronnie Harris of Event Skeptic.
I can't wait. This is so exciting. Globebusters have their first map, working map. It's
okay. The Flat Earth working map and model, macro to micro. Stars to the sun.
Will always be lined up where the north is.
Oh man, I just feel like I ate some manna.
Different grid work than this. It was just a rectangular grid work, but I forgot to adjust the angle. Timeanddate.com. It's 63 degrees. It's the sunrise angle. Was it 87 is the sunset, and
Tonight, live at 8 p.m. Central. Only on Beyond Flat Earth.
Hey, we are live. What is going on, everybody? Thank you all for coming. We're joined tonight by a super special guest, Flat Earth Math. His name's Charles. And of course, introducing my co-host with the most, Awake Souls. Take it over.
hello everyone, and hello Charles, and thank you for joining us. This is going to be fun tonight. So please, Charles, take some time to introduce yourself and why you are into this discussion right now, please.
Thank you very much, Ronnie and Jason, for the kind invitation. My name is Charles Breeling, also known as Flat Earth Math. I actually got started in the Flat Earth debate about 10 years ago. It was March of 2008. It was before it really hit YouTube. So my participation was on message boards. And the thing is, I feel very strongly that people should learn the truth, so the truth of the shape of the earth, the truth of whatever. And I also believe that people should be allowed to believe whatever they want to believe, but it seems that there's a lot of acrimony, a lot of bad feelings, bad energy, and actually on both sides. I mean, I tune into some Globe channels and it's just all this cursing and calling people idiots. And so it's like, I don't think that's acceptable on either side, but so I just want to try to be, a respectful voice in the debate. You can believe what I say and you can take my advice or not, but I don't want to, be a disrespectful member. And so civil conversation is very, very valuable. And the thing is, I know that you guys are flat earthers and I'm a globe earther. And so hopefully we will have a civil conversation. Maybe neither of us is going to change each other's minds, but hopefully people in the audience will, take something away from our conversation. So that's what I'm looking forward to.
That's our goal too. Thank you, Ronnie.
Yeah, well, what I was going to say was it's been about a year and a half, maybe longer, since I had Charles on. Me and Charles had a great conversation. We talked about the stars. We talked about this was before I met you, Jason, or just around the same time. So a lot has changed since that point. I ended up making a flat Earth perspective video where I show the CN Tower as depicted as a pylon. And I express how the further away from the pylon you get, the less you're going to see of it from the bottom up, and the closer you approach the CN Tower, you're going to see it from the top down. And this is on a flat Earth. This is the perspective, the way that I teach it. I know there's a bunch of other guys running around with some wrong math, some wrong perspectives, but that has stayed the same. The map has been completely changed. I guess my questions to you back then were like, what do you find the curvature? Could be a great question for the audience.
Was that for me as far as curvature goes?
Yeah.
Okay. So the word curvature has multiple meanings, and the one of the things that I find very, very important is to define terms. And so if there is a phrase that's 5 words long, and you can kind of shorthand the phrase with just one word, like people say, "Oh, I got a microwave in my kitchen," and it's like, you don't have a microwave in your kitchen. You have a microwave oven, but no one says microwave oven. They say microwave. Everyone knows what that means. But the word curvature can mean different things. The word curvature can mean the effects of curvature. Like I'm looking across and I see the CN Tower, like you just mentioned, cut off halfway from, I guess, what is it, Olcott, New York or somewhere. That might be the effect of curvature. The other definition of curvature, the other meaning, the informal meaning of curvature might be seeing a curve, seeing a curved horizon. And that's, people are always saying, "Oh, I looked at the horizon's flat." Of course, the horizon looks flat. But if you get up high enough, 120,000 feet, the high altitude balloons, you can see the curved horizon. So the word curvature, we have to kind of unpack what that means. Is it the effects of curvature here on the ground, or is it seeing a curved horizon at high altitude? And I think the evidence is there for both.
Okay. Well, how about you just, I don't want this to be like tit for tats and we're
sure,
fighting with each other. Could you take a little time and explain who you are and really how you got into this? Because I understand that you've debated Jaron and Globebusters and people like this. They've shouted you out before.
Yeah.
And
yeah, I'm blocked from I'm blocked from Globebusters channel.
Okay.
Not Jaronism.
Yeah,
but I just want to know who you are and how you got into this. I want to hear your backstory a little bit, please.
Yeah. Well, if you go back to 2008, there was and the thing is, I don't follow the Huffington Post, but I think I was following a number of political things, and politically, I'm conservative. But one of the things that conservatives in the United States have to contend with is the fact that the media is liberal. So, I'm always following up sources on both sides of the political spectrum. And so I think I was following a link that took me to the Huffington Post. And I saw this icon, or it wasn't an icon. It was a graphic. It was obviously done with, graphics. It was not photographic. It was obviously a graphic. And it essentially looked like the flat Earth map with the common AE, the AE model of the map, but the oceans were all blue and the land was green, and I mean it was idealized, and there were some grid marks indicating certain lines of longitude and latitude. And
but the context was that the sun and moon were doing circles around one circle,
circles around the North Pole.
Yeah.
Right. And so, and then the thing is, like, there are still people who believe, or no, the headline was something like the flat Earth society is sharing their map, or something like that. And I'm like, well, that's interesting. Because every time I'd heard of the flat Earth, it's the thing where it's like the waterfall, the endless waterfall off the edge of the Earth, from the legends and stuff. Oh yeah, the Earth is flat, and like the water's just continually flowing over this big waterfall.
You see the ship tilting over the edge, and it's ready to fall into oblivion.
Right. The what is that? Kansas, Point of No Return. That album, right? So I followed the link, and because I, was kind of curious. I'd never really thought about the Earth as being a circle with like an ice wall, or with like Antarctica circling it. So I followed the link, and then I just got interested, and I ended up joining a message board and debating flat earthers. And it was a lot of fun. And one of the things that was so fun about it was that it was all about concepts, and it was none of it was about people. And I mean that very, very sincerely. It was all about the concepts of flat Earth versus globe Earth, or actually back then we called it round Earth. It was FE versus RE, flat Earth versus round Earth. And there were very interesting people on both sides, but it was never, ever personal. It was never, the word shill was never, ever uttered. And I thought, so the debate was fun, because like you could actually disagree with somebody on the science of it, or on the math of it, or on the conceptual aspects of it. There was a lot of back and forth about gravity, how gravity was unproven and all this stuff. But it was like a fun debate. And then I kind of got away from it for a while, because it was very time consuming. And, I had to kind of focus on my job. I'm teaching, and then I've got a wife, and I guess I was newly married at the time, so I had to focus on that. But you probably hear my baby screaming upstairs. I'm like literally right. He's right above me. But so I kind of let it go for a while, and then I was doing stuff on YouTube, and then I kind of saw that the flat Earth has sort of made a resurgence on YouTube. Because back when I was a participant in 2008, I wasn't even aware of anything on YouTube for flat Earth. So I think one of the first things I clicked on was 200 Proofs the Earth is Not a Spinning Ball by Eric Dubay. I guess that's like a 2-hour documentary.
It's gone now from the searches.
What'd you say?
It's gone from the searches now.
Oh, really?
All you get is BuzzFeed and the Flat Earth Conference with Pat and Mark.
So that was very compelling. I could see his physics was dead wrong.
Many mistakes, right, in the book. Also, the measurement systems that he used and the actual measurements were debunked, right? I've seen the Eric Dubay 200 Proofs debunked, but some things that he did bring up were valid. That's where we get into this gray issue. But so I just wanted to address, before you keep going,
Sure.
So in 2008, you were on forums debating over flat Earth and ball Earth, because I have heard that also from Validation Boy. He was involved. I don't know about any of the pages or people that he sourced, or even him as a credible person, but I have heard, the only person that I've heard that flat Earth wasn't around was Math Powerland. He denies flat Earth being around in 2008. I guess he did his comedy skit in 2009, or I don't know. He's an absolute nightmare lately. But so back then, it was just a common debate between intelligent people coming to thinking and coming to conclusions. But now, the problem with the word shill is there are people entrenched in both sides of the debate that are actively shilling. We can use the term, the way that we describe the term shill, is someone who is either being paid or not paid, but is actively working against someone with false propaganda, basically, with lies. So, but see, it would be nice to have no of the name calling. I'm with you there. But when we have people on our own team that are putting out erroneous, obviously debunkable proofs, experiments, the circling sun thing, just the very fact on the equinox, the sun rises due east and sets due west, absolutely destroys the AE circling sun map. And we know this, so we have to call them out. I'm going to let you continue. I just wanted to say, like, if I could only just trade places with you for one day, Charles, if you could actually see, on your side, at least, most people believe in the globe. They're not trying to undermine you, whereas the flat earthers are just completely acting stupid, and it's been a battle. I can't even begin to tell you, brother.
And the one thing I'd like to add is that as you go forward here, if you could just think about, contemplate what you think the most damning evidence of the AE map and model is, if you could share that with us.
Well, okay, so let me take that second. Let me just finish up the next thing I started watching. This is back when I restarted my interest in flat Earth. So Eric Dubay was first, and then the Mark Sargent's Flat Earth Clues was second. And what was interesting about the Flat Earth Clues is it was more from a psychological, philosophical conspiracy perspective, with almost no science, almost no physical evidence, I mean, that's his take. And
just imagine, right?
But I mean, it's interesting because, the thing about conspiracy is it makes a great story. And so I got hats off to him, wonderful production values, he must have had a great mic, and then he had the wonderful slideshows. And so hats off to him for that. And then I started, jumping into YouTube, and then I had never really participated in hangouts before. So this whole thing about, being in a hangout and then having there be a live chat. So I started participating in the live chat, and people started, I forget when I set up my channel. It's interesting because I guess I set up my channel based on a conversation, not a conversation, but based on something Mark Sargent said. And very, very quickly, he said that he was talking to some scientist, some astrophysicist guy, and Mark, and I'm paraphrasing, Mark asked the scientist, if you were to prove to me that the Earth was a globe, how would you do it? And the guy thought for a moment, and he'd say, and finally he said, well, I'd have to send you up on a rocket, to like the ISS or something. Like that was his answer. Now, I mean, in all fairness, it was a spur of the moment question, and who knows how to answer those questions on spur of the moment. But that really got me thinking. And it's like, it got me thinking, like, how could I convince people of the shape of the Earth without sending them up on a rocket, And then, so that's when I started brainstorming the flat Earth. I call them flat Earth experiments, but you could say technically they're not experiments. And then I created my channel, dedicated to the math and science of the flat Earth debate. And I've got a bunch of experiments or explorations, if you want to call them. So anyway, that's sort of, then that brings me to the present. Now about the AE map. One of the things about the AE map is the angles just simply don't work. At first blush, the AE map, the northern hemisphere on the AE map looks kind of like the northern hemisphere on the globe. So the dimensions are a little bit off. But then things go really south. They go south as you go south. And like, Australia is like 3 times as long as it is wide. And, the thing is, I'm from the United States. And so I drive all over the United States. But like, one would think that somebody is in Australia might have actually driven north to south and then may have actually driven east to west. I mean, you think there are people in Australia that have cars and have actually driven, and they might actually know the shape of Australia just by driving it.
That's what Jason says. We commonly get shills. I'm going to try not to use that word. We commonly get people that are skeptics of what we're saying. And Jason says, listen, guys, you don't think if someone drove down the coast of the Florida Keys and it went west where it says on the map it goes east, people aren't going to say, hey, the map's wrong. We can see with our eyes the map doesn't match Google Earth. Like, that's what people deny, clear and day evidence, just like the rising settings of the sun. In the winter months, especially on December 21st, Wolfie did a great job documenting just how far south the sun was setting and rising. This is a completely opposite arc and turn. And Jaron from Jaronism, I debated him 2 years ago about it, Charles, and he acted like like he had no idea what I was saying. And I'm like, Jaron, you just need a compass, man. It totally shatters. The sun's not circling like this. It's going the other way. It's going down. It's going off the map, right? Continue.
Yeah. The one thing that I'm going to say about the AE map, and that is, it is absolutely correct if you measure north-south distances. So the AE map, you can actually make an AE map from the globe. There's actually an AE map generator online. I'm sure there's a bunch of them, but there was one where the AE map, the AE projection, the AE projection is actually used by airports. It's used by ham radio operators. It's used by, search and rescue squads. And what it is basically you plot anywhere on the Earth where you are, and you place yourself at the center. And what the AE map will do is it'll generate it's equidistant. So all the distances from you in all azimuths will be accurate. So what what we call the Gleason's AE map, you know, the famous one, the wall, I have a wall poster of it. The Gleason's AE map puts the center as the North Pole, and that it includes all the way out to Antarctica. But the thing is, what I would argue is that every single distance on that map, if you measure due north to due south, just pick anywhere on the map and just measure due north, due south, all those distances will be correct. Pick any series of points, as long as they're in a north-south line, meaning, you know, the line points towards the North Pole. Those
they only work laterally.
Yeah, well, you can only measure along lines of longitude.
Because as you traverse south, the measurements get blown out to infinity, right?
Well, the measurements east-west get blown out, or east-west, or actually on any other azimuth, east-west, and, you know, diagonally. But
Yeah.
but if you measure even
all angles, right?
Well, not all angles except north-south.
Okay.
North-south, like even if we see that Australia is really distorted, but if you picked 2 points in Australia one was due north of the other point and measured it and then used an actual ruler, that distance would be accurate.
So would you agree that we could use the AE map as a clock?
You can sort of, because the sun, like if you project the globe onto an AE map, yes, the sun then looks like it's doing a circle around the North Pole, and the sun will do one turn in 24 hours. So what we want, one solar day. So yeah, you could use it as a clock, but you know, things like the physics of it get really problematic.
Yeah. Would you assert that we would ever be able to navigate by an AE map?
No, absolutely not.
Okay,
Absolutely
good.
not. You know, where the AE map is fine. Like what's really interesting, when I started searching for a poster, like I wanted to buy the Gleason's poster. And I think maybe I didn't know it was called Gleason's. I just knew it was called, you know, AE or, you know, azimuthal equidistant. So I went to Amazon and I typed in, you know, poster or equidistant azimuthal poster or something like that. And what was really, really funny was there are posters where the center is various cities around the world, you know, and it's because the AE is a projection. The Gleason's sticks North Pole in the center. But you could pick any point to be the center. So there was an AE map where it shows Paris in the center. There's an AE map that shows Rio de Janeiro in the center. And then the whole rest of the world is sort of, you know, distorted out. But like everything near Rio de Janeiro looks perfect. But the thing is, you can measure the distances to Rio de Janeiro. I don't know if I'm making any sense. But
you could do this with any type of map projection or model.
Yes, absolutely.
It doesn't validate the map nor discredit it. But we do know that the dome over top of an AE map with a circling sun, you know that it doesn't work. And you've been out here trying to teach people this very same.
Yeah, and really trying to teach people to make careful observations. And one of the things that really is refreshing about the two of you is that, and I was watching, you know, one of your shows from a couple of nights ago, and I shared this in an email to you, that you guys seem to have figured out that there are patterns to the motions of the sun, and there's patterns to the motion of the stars. And if you pay attention, you can actually learn a lot. You know, like if you're in Australia, the sun sets headed south. You know, it's like, what on earth is that? How could the sun be headed south? You know? And then like the whole thing about the North Celestial Pole and the South Celestial Pole. You know, most flat earthers deny the existence of a South Celestial Pole.
I want to ask you something. I want to stop you right there. I want to hold you up. This is a common thing that I have with flat earthers. Maybe you could give me some advice on how to deal with them. We do, everybody at home, me and Jason do believe that we can prove the earth is flat. Charles is on the ball earth. That's fine. We're not going to fight over it. But the fact is that there is a southern celestial star rotation. It goes clockwise, and there's multiple different constellations that you can pinpoint. And the most noticeable is the Southern Crux, which is a cross in the sky that rises to the bottom left of Sigma Octantis. And you can measure off the bottom of the cross the exact same way that Ursa Major, which I call the Big Dipper, you count down to the bottom of the Big Dipper and you can measure to the North Pole. I can do this in a matter of seconds. How do I go about telling people the Southern Star Trails are real? What would you say is the best way?
Well, unfortunately, one of the things that I've come to realize in the flat earth debate is you can't tell a flat earther anything. You know, it's like you have to show it to them. You have to get them to discover it for themselves. And most flat earthers are in the northern hemisphere. I mean, most of the world's population is in the northern hemisphere. And so there's tons of videos, even videos made by flat earthers that show, like, you know, star trails, or it's a video where it's either a time lapse or it's a guy who, you know, took a picture. I think I saw one guy, he took a picture where you could clearly see the Southern Cross. And then he said, well, it's 9 p.m. And then he came back at midnight, and then he took another picture, and you could see that the Southern Cross had moved, and you can actually see that the angle had changed, you know, and it was at a different, you know, slightly different place in the sky. And so it's like he was clearly showing that the stars are going in a clockwise fashion, and around the South Celestial Pole, which, you know, the interesting thing about the South Celestial Pole to me is that there's very few naked eye stars. In fact, there's almost no naked eye stars. If you have a telescope, if you have very long exposure, you could see the stars. Like even Sigma Octantis I don't think that's a naked eye constellation. I'm sorry, Sigma Octantis is the star that is closest to the South Celestial Pole. The constellation is called Octans. But it's very, very dim stars. Unlike we in the northern hemisphere, where we have the Big Dipper, which is, you know, magnificent, and then it points to Polaris, and Polaris is pretty bright. Not exactly at the North Celestial Pole. But to answer your question, how do you convince somebody? You can't. You absolutely can't. You can try to point them in the direction of the evidence, but if they don't live in the southern hemisphere, that they can always just say it's fake, you know, or that they're running the video backwards, you know.
What about 2018? Don't we have, even though the majority of the population, like you said, is in the northern hemisphere, don't we have millions of people in the southern hemisphere that can confirm this for us?
Yeah, but what if they're all fake? What if they're all lying? You know, they're all part of the conspiracy to hide the truth from us. You know, it's very discouraging to try to talk to somebody who, and you know, the thing is, and I don't want to insult anybody, I don't want to step on anybody's toes, but if somebody has a genuine belief, they're going to reject evidence that goes in opposition to that belief.
That brings in another topic about the 24-hour sun above the horizon.
Mm-hmm.
I'm guessing as a global believer, you are going to insist that there is a 24-hour sun above the horizon that millions, if not billions of people, we don't know the true numbers in this world, should be able to go into the Arctic Circle and witness a sun that never sets for, I think the globe model promotes something around the neighborhood of 50 days that it never sets in the north or never sets in the south. Is that true?
Yeah. Well, it's actually even worse than that. If you're actually standing on the North Pole, technically, and this is technically, there's only one day. There's only one day on the North Pole, meaning
one rise set.
Right. If you're standing on the North Pole, in one calendar year, in 365 days, the sun will rise once and it will set once.
Yes,
I thought the sun is tracing us. You know, it traces the horizon. So, you know, I'm making it seem more exaggerated because the sun is never going to go up. If you're standing on the North Pole, the sun is only going to go in this horizontal band, and it's going to very slowly creep upwards, and you know, and then it's going to very slowly creep downwards. But you know, technically, one day on the North Pole is 180 days long. You know, now the South Pole is a little more problematic because there's a lot of mountains, so the sun will keep peeking in and out behind the mountains.
Below the
Charles.
Yes,
I just want to stop you right now. The people on our channel are very sensitive to like the 666 sign, okay, and things like that. So I'm very careful to not use those things and put, you know, any sort of satanic emblems on me or anything like that. So just be careful with your hand gestures so that people don't construe that you might be a Freemason.
Yeah,
right?
At least you have to go like this. You have to make it complete, or like this. Chopping motion works. Because people really get going with that.
They get triggered. They get totally triggered.
Yeah, if you do any Masonic poses, if you cover one of your eyes, if you do the 666 signs, you're a satanic shell. We want to warn you about that. Look at his face; he's laughing. But you know, just to bring it back to the point. So when I did my research on the heavenly luminaries, and what you'll call the celestial sphere, I came to the conclusion that that there is different ways to project the sky and the earth. The two-dimensional plane that we live on, that we believe in, has to be a stereographic projection of both the celestial charts and the earthly plane. And we do have a coordinate. I will get the celestial coordinate map out. I use it in a few of my videos. But about the 24-hour sun. So we would say that the challenge is there's only like one real 24-hour from the north sun, 24-hour up all day sun that Simon Wilkes, I think, was the creator, and it's under animation, by the way. It's a Blender creation. Why is there no footage? I know, like you had said before, the bias sets in my mind until I see it, or is everyone in the north lying? But for me, the fact is I can find tons of evidence of the southern circumpolar star trails, but I can't find any real up all day. Now, I've contacted people in the Arctic Circle, scientists that shoot up balloons. They ignored me, would not respond to me. I've made other calls, and nobody from any of the northern cities have ever photographed this. Now, I also have an uncle that just got back from Grand Prairie, northern Alberta, Canada. It's way up there. It's pretty north. And he does say that the sun sets at 11. Some mornings it comes back at 4, and the twilight stays out all night. So my question is, the twilight is what I believe is what lights the sky. The sun rises and sets once each day, like it says in the Bible. It doesn't say that specifically, but it says the sun rises and the sun sets. And the twilight stays out. This is what I'm willing to debate. So my question for Charles is there any way we can verify this without using any CGI?
Yes. The thing about YouTube, I'm sorry, I just adjusted my glasses and my hand might have been in a 6.
No, that you were good there. You were good there.
You're good. I'm just warning you that our audience is sensitive, and when they see things like that, they may get triggered.
Yeah. Well, the problem is that I tend to talk with my hands, and I talk with my hands even when I'm on the phone, and so
you're not Italian, are you? Are you Italian?
No, I'm not Italian, but I'm a very visual person. And so if I can draw it in the air with my hands, or even if it's just me just gesturing with my hands. So anyway, I'll try to be.
It's more for the Christians, because I believe there's a campaign to indoctrinate people on YouTube with the signs and the symbols. Okay. They don't really have any power, but once you start learning about all these signs and symbols, people's brains go crazy. And we're just trying to, as Christians, that's the only reason why Jason brought.
Yeah, and I appreciate that, and it's always good to be sensitive to people's, what triggers them, or what is sensitive to them. It's good to be mindful of what other people find sensitive. But getting back to YouTube, it seems to me in the flat earth debate community that if there isn't a video on it, it doesn't exist. And I know that's not what you were saying, but when people say, like, for example, spacesuits haven't ever been tested in a vacuum chamber, or at least the one time they did test it, the guy almost died because there was a problem. And it's like, okay, so maybe that's on YouTube. So it's like,
have you seen that footage where the guy falls over backwards?
Yes.
That's pretty horrendous, man.
But the thing is, people don't understand how human testing of spacesuits actually works. Like, what are the logistics? And you certainly don't use that thing with the big bank vault door, which is where they did that test with the feathers and the bowling ball, or it's got this huge door the size of, like a 3-story building, and it looks like a bank vault door. You don't test humans in that. And the reason why you don't test humans in that is because you can't safely depressurize and open the door in any kind of reasonable time. But anyway, so the point I was trying to make about YouTube is that if the YouTube video doesn't exist, people think that the concept doesn't exist. And the thing is, if the YouTube video does exist, then it could be called fake or CGI. So, the 24-hour sun, there's tons of 24-hour sun videos that I've found. There isn't really a whole lot up at the North Pole, because the North Pole is shifting ice, and sometimes there's ice-free seasons in the North Pole. So there's there's no buildings at the North Pole. It's the Arctic.
The globe model requires it in both the North and the South equally.
Yes.
So could you point us to some footage that you feel is legit of a 24-hour sun that never sets for 50 days?
North or South? Either
Yeah,
way.
well, the ones that I've focused on, like when I was doing a search, and I'm not going to do a search right now, and I don't have this footage at hand, so I could easily email it to you, and you could, show it in a future episode.
Yeah.
But there were a bunch of footages taken of some of the various stations in Antarctica, and there was one where what somebody had done is they actually looped the footage, and so it's not 24 hours. It looks like it's about 30 hours, but 4 of those, or I'm sorry, 6 of those hours was actually looped from the beginning. And so therefore people say, oh, look, you could see where it merges back into the original footage. And somebody was being artistic. I don't know where the original footage was, but somebody was being artistic.
Is this in the South? In the South? Because
that was South, not the South Pole, but it was Antarctica.
Because Jason, sorry to interrupt you. You can go 1 second. Jaron did a great job actually exposing the fact that the sun does rise and set. He did a video that showed shadows jumping, and the time actually matches 24 hours. The time doesn't jump; it stays the same. So what we were professing was that was evidence that the sun was setting and rising each day throughout the year. Go ahead, Jason.
Well, I just, in this day and age, where there's people all over Earth, be it whatever shape it is, you would think it would be something of admiration that people would document a sun that never sets for 50 days, where you could see it just circling and circling and circling, and it never sets. And yet there is no evidence of that for the North or the South. And Ronnie and I,
it would take 24
I assert that this is evidence that both the globe and the AE map and model don't work.
Just 24 pictures. That's all we need, Charles, with a compass and a camera and showing the sun's azimuth. 24, 1 each hour. Boom, click, 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 click. And 24 pictures would be more than enough evidence to prove me wrong, prove Jason wrong. And no one's even tried to fake it. That's what gets me. There's absolutely no footage, right? We've searched high and wide, YouTube, all the different search engines. I've gone on DuckDuckGo. I've looked on, Vimeo. I've looked everywhere, Charles. I've looked at libraries, and I cannot find any footage of a sun that does not rise and set once a day. And online, you'll find watch the midnight 24-hour sun never set. And then it says, as it sets, and you watch the video and it sets. It's like, I can't, that's my only issue with it.
It burns us up. Like, you would think that there would be evidence for it, right?
Oh, sorry, I was on mute. Yeah, the thing is, I've done similar searches, and I've found, a bunch of videos that some of them were of shadows, where you could see the shadow kind of tracing a circle, around,
and jumping.
And then there, well, if you look at for the edited one, the thing is, anybody could do anything they want with footage, And so the video that I saw, the shadows were not jumping. Now, the thing, you have to think about the logistics of if you wanted to film a 24-hour, like just the 24-hour of shadow going around in a circle, you have to have perfect weather. You have to have no clouds for 24 hours. And it's like in Antarctica, they've got some pretty crazy weather. I mean,
no, I've heard they have the lowest amount of dust and dirt in the air. So the least amount of clouds, I've heard.
No. The lowest amount of dust and dirt. Yes, it's extremely clean air. But some of the storms they have are, it's something straight out of a science fiction movie.
But the sky...
That's not 365 days a year, is it?
No. But what I'm saying is you have to think about the logistics. And so if you want to have shadows that trace a perfect circle without any kind of, what you call jumping, sometimes what is the shadow disappears. Like the footage that I saw, there were times where the shadow disappeared.
Every one I've ever seen. From the south.
But so that's one tact, is to have a footage where it's, aiming at buildings or aiming at a flagpole or something on the ground. But the other one is when you aim at the sun, you have to have a tracking camera. And so the one example I saw of that was, I think Jaron tried to do a takedown of it, and he's like, oh, look at this in the credits. It's like, thanks to Ball Watch, like, what's Ball Watch? As if it's like Globe Watch, what's Ball Watch? So it was part of the conspiracy. And so I looked it up, and it's like, they were the people who made the watch that was in the video. The company's name is Ball, and they make watches. They make very expensive watches, with where the minute and the second hand, or the minute and the hour hand. And
probably
so
diamond crusted, right?
Yeah. But I don't know if you know the video I'm talking about, but basically it's the sun is center frame, at least left to right. Okay. You can see the sun go up and down in sort of a sine wave curve, because the video was not shot at the South Pole. It was shot at one of the Antarctic stations. So the sun is up for 24 hours, and that you can see the sun rising in the sky and dropping in the sky, but the sun never goes below the horizon.
So is the sky blue? Does the sky stay blue, or is there twilight colors?
There's no twilight colors, because but the sky is like, blue or white. I mean, there's clouds. So like, when it's kind of a cloudy day, the sky isn't necessarily blue, but there's no twilight. There's absolutely no twilight. Twilight is definitely when the sun's below the horizon.
Really? Not when it's getting, because I have multiple different evidences that I go to for my research that show that there is always the twilight colors wherever we are. And there was, Captain Cook, I know, and a lot of people, I don't really like their evidence. Robotham as well, who I don't really like all of his evidence either. But they both said that they admitted seeing in the northern and the southern region beautiful twilight colors, to the point where they were in tears in some of the books. And I just had wondered why all the faked footage had no twilight.
Yeah, well, the thing is, you're not going to get twilight unless the sun's below the horizon. Now the thing is, it all depends on the season. So it's like, you could be pretty far north and then have the sun still set. In
Buildable, Alaska, I can watch a 24-hour cam, and it shows amazing, beautiful sunsets in the summer region, where the sun is only supposedly circling. The Arctic Circle. What is it? It's a 40-minute drive from Barrow, or where was the other footage we have from Dawson Creek? So we've actually gone and seen this. So how would the sunset be working in Barrow, and then not 40 kilometers north of there? It just disappears? Or you're going to say maybe it's beyond the curve? Maybe.
Well, what I would suggest is that you make sure you compare apples to apples. So oftentimes people take a look at one footage and they're like, oh, see this, and then they take a look at some other footage and they're like, oh, see, it shows something else entirely. And it's like, yeah, but it was a different camera, it was a different different focal length of the lens. It was a different season. And so it's like, it's really, really you have to be really careful. So if you have footage shot from Barrow, and then you go 40 miles north and it's like the Arctic Circle. Well, the only time the Arctic Circle really is important is on the solstice, either the December solstice or the what's the other one, the June solstice.
But any point from the Arctic Circle inward to the North Pole would have a never setting sun for, what is it? Is it 50 days? How many days is it for the globe?
But if you go like one step inside the Arctic Circle, you may get one day where the sun never sets.
No. Inside the Arctic Circle, it shouldn't set for 50 days,
nope.
Or 55 for the.
I don't think so, unless they're taking into account the fact that the sun has a half a degree diameter, and so we call sunrise and sunset when the top of the sun clears the horizon, versus the center of the sun. And so maybe the Arctic Circle is the place where the center of the sun is tracing that path. Does that make sense?
That's interesting. Go ahead, Jay.
We could right now pull up a YouTube search as to how many days it's supposed to be up. I know when Ronnie and I were searching this, we came across something like a Fox, 666, and I don't know, it's probably some channel like 66 or something in Alaska that was covering the never setting sun. He was like the meteorologist that was promoting the idea that the sun never went below the horizon for some 50 or 55 days. Is that true? He's muted. Ronnie? He's muted.
I'm sorry. I had muted myself. I try to mute myself, so that just to kind of keep.
We're good. We're good. You don't have to mute right now.
Yeah. So I apologize. Part of my what I said was I was on mute. I am not an expert at like how many days per location. But what I can say is that the definition of the Arctic Circle, it is like 23.5 degrees away from the North Pole. So it's sort of a geometrically perfect number, matching the Earth's tilt. Okay. Now the thing is whether the sun is rising or setting, or whether it's, a 24-hour sun or not, depends on where the sun is, like where the top of the sun is compared to the horizon. And so it could be that maybe there are places that are, like a couple miles south of the Arctic Circle that experience 24 hours of sun. This is not an area that I'm really, an expert at. What I want to say is I just posted something in the side chat in what's this technology called? Zoom. So in the side chat, I posted a link to a YouTube video, and this is the one that was covered by Jaron, and it's from a documentary called Antarctica: A Year on Ice by Anthony Powell. And
you're not going to reference something that Jaron promoted, are you?
Well, I think the problem with this one,
he tried to debunk it. Is what
David Weiss debunked it, because the peak of the, here I can show you guys. There's actually a peak that shows that has no snow on it, and then at the end of the video, when it does its 24 hours. It's got snow again. So you can see, can you guys see? I think David Weiss probably engineered this, or there was another guy, friend of Yahweh. Do you guys know him?
No.
I've heard of him.
So if you guys put your attention to this peak here, there's no snow on it. And then when we go all the way to the end, when we come around, I believe it's now a snow cap, right?
But that's not the same peak.
We've gone past it. Is it that peak?
Nope. No, that's got a pole in front of it.
Maybe this is different footage. Must be. Yeah, maybe. I think they've clipped the video.
Now, the thing is, anybody is welcome to go see. Apparently, the Anthony, his video. I'm sorry, it's his documentary, Anthony Powell's documentary, Antarctica: A Year on Ice. It's a commercial documentary, so it's not streaming free on YouTube. But one of the things that the guy, I think the guy was standing in front of the camera, and he's like, okay, he has a verbal introduction, and then that mountain does not have snow on it. But then when the time lapse starts, the time lapse is not recorded the same day. The time lapse shows the mountain with snow on it. But the camera location is completely different. Obviously, it's a different season,
Yeah, and the camera jumping is a bit.
But no, the camera doesn't jump at all on this one, and so that's one. And the one that I was thinking of was the one that was sponsored by Ball Watch, where they actually have a watch in the frame. Let me see if I can find.
Yeah, that was the other one. Yeah, I remember that one too.
Yeah. But so the thing is, it appears as though we're spending a whole lot of time in our conversation talking about Antarctica. There's like
we can talk about whatever. What would you like to talk about?
You brought up our points, and you've brought up yours. Like I said, that was a great discourse. But where would you like to go?
Well, really, the thing is, and the thing I want to attract your attention to the celestial sphere, because that seems to be an area where you have done some study, and the celestial sphere tells you everything about the shape of the Earth. And the reason why it does is that every point on Earth has a band of stars that passes directly overhead. So, for example, I'm at 40 degrees north latitude. I'm very near Philadelphia. Well, and I forget what the names. It's right ascension declination, but basically the celestial sphere is a map of all the constellations. every constellation has constellations to the left, to the right, above it, and below it. And so you can map these constellations out, and it maps a sphere. Doesn't map a dome, and it doesn't map a flat plane. So you can map the celestial sphere. I mean, like, you could take very, very careful photographs of all the constellations and just map them out, and you'll get a sphere. Okay. But the thing is, the stars on that celestial sphere pass over different parts of the Earth. So, for example, here near Philadelphia, if I had a telescope, which, I mean, I've got a cheap telescope, but if I could point it directly straight up, 90 degrees straight up, there will be stars that will pass in front of my telescope. Now, if I look up into one of these star catalogs, because all the stars have names, and some of them are in constellations and some of them are not, I will find that the stars that pass directly over my head will be at 40 degrees north of the celestial equator. I forget what that's not right ascension. It's declination. I guess it's a positive 40 declination. Now you're in Texas, right? So Texas, yeah. I'm thinking your latitude is like 30 to 35. Jason, I mean, Texas is a huge state.
I think 30. You should pull up the website that we use, Jason.
Well, it's 30.
Okay.
Charles,
okay. Well, let's just say 30, right? So if you have a telescope in your backyard and you follow the stars as they go overhead, you will find the stars that go directly over your house to be the ones that have a 30 degree or a plus 30 declination. And you can look them up on the catalog. Yeah,
you can subtract it from 90 and find your latitude, right?
Well, no. That's if you were looking at the Polaris. I'm sorry, that's if you're looking at the celestial equator.
That's right.
If you point your camera south of you, if you're in the northern hemisphere, so you're in Texas, if you point your telescope towards the south and then elevate your telescope until you see the celestial equator, like, for example, if Orion goes overhead, the winter months, Orion goes overhead. If Orion is due south of you, I think it's the left hip. I think it's Mintaka. I think it's the left hip of Orion is actually on the celestial equator. And again, don't quote me. I'm just going by memory. But if you measure the angle of elevation, yes, that will be 90 degrees minus your latitude. Yeah. But the point I'm trying to make about the celestial sphere is that if the star that goes overhead at my house is different than the star that goes overhead at your house, and then the people in Australia, the stars that go overhead at their house, I mean, somebody is underneath the Southern Cross. Like there's a place in Australia where the Southern Cross is exactly 90 degrees overhead in some evening, of the year. Does this make sense? And so it's like if you've mapped out a celestial sphere and then you find points on Earth that are directly beneath points on the celestial sphere, that indicates that the Earth is in fact a globe. I mean, that's not the best proof, but that's a piece of evidence is what I'm trying to say.
Wait, you do understand the map and model that Ronnie and I have been promoting for well over a year. What is it? It's a year and a half. Uses all the calculations of the globe model. Okay, it mimics all of them to a T, but it's done on a flat plane, right?
I would disagree about that. It matches everything that's on the globe. It's mapping from the globe. Like, for example, I sent you to that website that was a mapping. It was a map generating website, and it had a whole pull down menu of like 50 different maps, and one of them was Mercator. And so you can produce that map from the globe, and you can produce 1,000 other maps from the globe. But the problem with a flat Earth map is that the angles just don't work. Like the angle of say Polaris, if you look at Polaris from your house in Texas, it will be 30 degrees above the northern horizon. If I look at it from my place, it's 40 degrees above the northern horizon. And that doesn't line up with your map. The angles don't, if you have a flat map, the location of Polaris in the sky is the same for everybody on that map.
Do you know what a stereographic map is?
I'm not familiar with stereographic, but no, I'm not.
Okay, so it's a map that when you project it to a 3D sphere, you can take a 2D map And because it's stereographic, when you project it to a 3D sphere, it would do the same thing as projecting it to a globe, right? So Ronnie's pulling up the video right now. What we do promote is a stereographic map, which is a two-dimensional flat map that you would be able to navigate by. So you would be able to actually dead reckon across this map just by drawing a straight line from point to point. And you could draw that line in the map, and when you project it to a 3D sphere, what you would end up with is something that looks like a great circle route. Do you know what those are?
Yes, I'm very familiar with Great Circle.
Or a room line. A room line is another.
Yeah,
way
rum lines. The problem that I have is that it's like the putting the cart before the horse. So if you have a map that can be mapped onto a sphere, meaning like wrapped onto a sphere, like let's say your map was made of a sheet of rubber, and you could stretch it so that it covers the.
This here map was actually created with the least amount of distortions.
Yes.
And that's so what you're talking about there. So when I go to this, where the way that we got this map, I can just show you. I don't know if you've seen this. I'll go to the links here. I just want to show you, because I know where you're going with this, because there is supposed to be distortions, but there's not. I don't know why this is not letting me do this.
Well, the thing is, you say least amount of distortion. That doesn't mean zero. And so one thing that gets hugely distorted in your map is the Pacific. Like the entirety of the Pacific Ocean is completely distorted. And so if you were to pay attention to, say, where's Hawaii, where are the Philippines, where's Japan, where's Micronesia, if you were to pay attention to where all those islands are, where's Easter Island, okay? If you pay attention to where all those islands are and then map them, or then locate them on your map, you'll find that they're hugely distorted.
I'm gonna have to disagree with you here. I'm gonna just read this to you quickly. So this is the map here, but it's displayed in a incorrect orientation, because that's what artists or cartographers wanted to do. So this stunningly detailed satellite image. So they're proclaiming that they flew over satellites over the Earth. So the satellite image of the world, detailed land cover data depicted in an oblique Mercator projection. So what I'm saying is they probably through YouTube high altitude planes is how they probably measured this. The parameters of this map projection have been carefully chosen so that the inevitable distortions that occur is regulated to the oceans in the least populated and the least recognizable land masses. The result of this is a uniquely interesting flat map of the world that exhibits nearly no distortion in the most familiar places, even at the poles. This version of the map has been done in a stylish portrait, perfectly suited to hang on your walls, an elegant piece of art. So not only that, we've taken this map and what we've done is we've kind of orientated it in a correct position. But out of all the maps that have ever been created, Charles, this is the closest you're ever going to find to a globe. And when we project this to a sphere, every single measurement that you talk about aligns. And not only that, but we also have a stereographic projection of the sky that goes over top of this map. And then it then charts and gives us all of the angles and rises and set times. And all of this has been, so we're just showing you this. I know you can debunk it or whatever, but we would hope that you could help us besides. So you're saying, let me guess, the first thing you're going to say is probably these land masses around Russia and Alaska are probably skewed, right?
No, that's not what I was going to say. Most of the land masses, most of the continents, in fact, I would say all the continents on that map are distorted very little. Now, the one thing, if you do take a look at South America and Africa, in the actual globe, which I believe is the true shape of the Earth, the South America and Africa fit together like two puzzle pieces. I mean, you could literally cut out. I mean, the thing is, you can't do it on paper because a paper is a paper map. But if you take a look at an actual globe, and you take a look at the coastline of Antarctica and the coastline of Africa, they fit together like two puzzle pieces. And this map clearly does not show that. But if you go to that caption, the caption that you were reading, it said it has the least amount of distortion where most of the population is, or something, or it says where the least population is So in other words,
Right.
if you live in Polynesia, there's 1,000 islands in Polynesia. I don't quote me on that. Well, then you're going to be actually on like 4 corners of that map, because Polynesia got split up. Because where's the Pacific Ocean on that map? The Pacific Ocean is actually, I think, on all 4 corners of that map. So the Pacific Ocean got thrown under the bus, to make that map. Does that make sense?
Well, what I'm going to say is, I'm going to just boldly say that this map was created in 1894, and I'm going to bet almost $1 million that if I had $1 million, they didn't have a proper projection of the globe until this oblique Mercator cylindrical conformal CS Pierce map was drawn in 1894. And I do believe this is the most accurate 2-dimensional flat representation of our Earth. And I would like any scientist, any cartographer, or anyone else on the face of this Earth to come out and debunk us on that. And this is what truly, if there is going to be a flat Earth, if the Bible is true and there's 4 corners and the Earth is fixed, the Earth is stationary, this is the only map that we can actually measure the sun's movements and the heavenly bodies moving across and around the face of this map. This is the only one, Charles, that we have found. And if you can come up, pretend maybe that you're not a ball earther and do a little bit of a skeptical, if you could find a better or more accurate map than this one, we would be so thankful to you.
Well, here's the thing. And then just off the top of my head, take a look at Africa, and notice that the southern portion of Africa, South Africa, is hugely distorted. But then what happens when you go due south of Africa?
We want to know that. We want to know.
No, but I mean, you could actually rent a charter and you can go south of Africa and you could hit Antarctica.
No, look, let's go back to the map. And where would you hit if you went due south from the south?
If you went due south of Africa, you will hit Antarctica in the real world.
No,
on that map, it's not.
Then
possible.
why is there no chart? Why is there no? Am I muted? Why is there no charters or tours from there, Charles? There's nothing from there.
It happens to be that Africa, the southern tip of Africa, is further north than the southern tip of South America and the southern tip of say New Zealand, right?
But
so most of the charters that are going to be toward to Antarctica are going to leave from the places that are the closest. But that doesn't mean that you can't get there. Like if you literally went due south of Africa, you'd be able to get to Antarctica.
Yeah, but if you do the research on how long the trips are from South Africa to Antarctica, these are 10 and 11 hour trips that are completely incongruent with Australia and South America, like in the globe model.
No, not with the globe. If you actually hold a globe in your hand, not that map, but if you actually hold a globe in your hand and then you find, what's the flight time from this point to that point, and then you stretch a piece of string to simulate the Great Circle route, you're going to find it to be completely lining up. So, but here's a question for you about this map, because I totally. Go ahead.
Yeah, I just wanted to say to you, so do you see these 3 lines here?
Yeah, those are the tropics and the equator.
That's correct. So what orientation or shape would you think this would take when I project it to a sphere?
Well, no, if you projected that onto a sphere, you're going to get the globe Earth that I believe in.
Yes.
This is the map.
Yes. Yes.
But every
yes.
Woo! We got it. We got it.
Yeah. That's awesome.
You guys are funny. No, seriously, every single map on that list, and there's a whole bunch of them. Gall Peters, conic projections. Every single map on that list. Every single one of them maps to a sphere.
But
list and try to project
no,
it to a sphere.
Yeah, Charles, we've gone through all the maps, including the AE map. And we found that each one of them did not actually wrap the entire surface of the sphere. Many of them left huge gaping holes. The AE map, obviously, there's like 3/4 of the ball missing.
No, the AE map will only distort the South Pole. That's the only thing that's essentially missing on the AE map is the South Pole.
And when you project the regular Mercator, you have no North or no South Pole. You have to trim them.
Right. The North Pole and the South Pole are both distorted on the typical, classroom Mercator projection.
But this
wall
map,
Mercator.
this map right here, if you get the mesh networking right on Blender, the North Pole is completely on the North Pole, and Antarctica
Sure.
wraps together like your duck finger. In a absolutely, it takes minimal amount of work.
Oh yeah, no, you have no argument with me there. and the map that you said was drawn in 18 something or other, that was an actual representation of the globe projected onto a flat Mercator, projection.
Well,
In other words, the globe was first, and the map projection comes second.
We assert that it's the other way around.
Yes, well,
Yeah,
obviously we're going
I
to
get that.
disagree, but
I get that. But here's a question for you: is Antarctica 2 continents or 1?
it's split into 2 though, but it's 1.
And so like, okay. Well, and then that's the other question I have about your map is what happens when you fly off the edge? Do you, the cartoon version is, do you teleport, like Pac-Man? But like, what is your thoughts on that?
Asteroids, not Pac-Man. So Pac-Man
Asteroids.
Asteroids. Right.
I can't hear you, Jason.
Pac-Man has just the one
Jason.
dome that goes through the one port and shows up on the other side.
He's really quiet.
Asteroids-
Jason, you're really quiet for some reason. Your mic is quiet.
I don't know what happened, but I can carry on while he gets that. I don't know what happened to your voice, Jay. The asteroids is the thing is we don't know of any circumnavigation north to south to south to north. Go ahead, Jay. Maybe if I stop screen sharing. Try again, Jay.
Is it any better?
No, it's really quiet.
Okay.
But yeah, so what the other thing is, I guess I can go back to the screen share. So the north to south hasn't been done, but basically, and traveling anywhere from east to west. So what is the globe? The globe Earth is how many miles? It's 24,000. What is it? Oh, you're muted again.
I'm sorry, 24,900 approximately.
Approximately. So basically, starting from any position, well, depending on it actually follows the exact same measurements that the globe would follow. But the thing is, this line here is just a representation of where we want to project where the map would end and start. But really, it's a flowing system. So, if your edge is here, if you travel this way, it doesn't make any difference. You're still going to have the exact same results. We've never left Earth and gone into space, in my opinion. But we can travel east-west. I would like to know about the north to south. That's the only question I have. But there's no jumping anything. This is just the way that it works in reality.
I'm sorry, I muted myself again. So here's a question for you. So we have astronomers, or actually we have flat Earth people in all the continents. I'm most familiar with. There's a couple in Australia and there's a couple in South Africa. I think Cosmic Surfer is in South Africa, if I'm not mistaken. So if he looks due south of his location in South Africa, he will see the South Celestial Pole above his horizon. So you were disagreeing with me that you'd get to Antarctica, okay?
At 180 degrees, right?
But hopefully,
Is that what you're saying? 180 degrees south?
Well, no. What I'm saying is he's standing in South Africa, and the azimuth, 180 degrees south. Yes.
Okay. So what I'm saying,
due south.
If you look at these lines here on the map,
Yes.
they look kind of funny shaped.
Yes.
But these are your actual. So this would be all the calculations. This would take you due south. So as you can see on this map here, what it does is it relegates having a magnetic north. A celestial north, because it's always pointing back to this spot here, right? When you follow these lines.
Yeah, but where those two poles, the North Pole and the South Pole on this projection, are not actually where the magnetic poles are. I get what you're saying, how there's these
You're
curved
saying
lines.
you're saying no. See, the curved lines actually relegates that issue.
Well,
anywhere along this chart, when you use your compass reading, you're going to be heading to the north when you follow these lines.
oh yeah, when you follow those lines, but in reality, those lines are actually straight. So that's one of the problems.
Yeah, and in reality, the water that we see amongst our Earth is actually flat.
No,
right?
It looks flat.
No, but it's measurably. That was good. I got you there, right?
No, you didn't get me. It looks flat.
In reality, we have to have a secondary map that tells us where our compasses are off to readjust our headings because of the magnetic maps, right?
Declination, right? The magnetic declination, which is very strong in the southern hemisphere.
So
But
we could go into the maps actually, or the stars. I could get a video up of the
oh
stars.
yeah, but the thing that I want to emphasize with your map is that if you follow those black lines that essentially look like lines of longitude, you know, the ones
Correct.
that are the ones
Correct.
that intersect the South Pole and they intersect the North Pole.
Correct.
Each one of those lines, like, you know, just zoom into some country in South America, zoom into some part of South Africa, zoom into some portion of Australia, and look at that quote unquote north-south pointing line, and they're going to be at 3 different angles on that flat map. Whereas, in other words, they're going to be South America is pointing off to the lower left. The one in Africa is pointing almost straight down. The one in Australia is pointing to the lower right. But yet they're all supposed to be looking at the same south celestial pole.
But the maps that we use today, in conjunction with a magnetic declination map, do the exact same thing, correct?
No, they don't. And the thing is, you can throw the compass out the window. You can, for example, you can find where, like in Texas, you could find where truth south is because it's when the sun is highest in the sky.
And
So if you throw the compass out, I mean, the compass is a measurement of magnetic force, and it doesn't line up with the north and south pole exactly. You could throw the magnetic compass out the window and then still figure out where north and south is by, you know, looking at rising and setting stars, rising and setting
there.
You know,
because those are the apparent positions of the rising and setting of the sun and the stars.
Well,
So
apparent.
I get apparent, but here's the question for you.
We're kidding. There is no parent. We don't do a parent.
We don't preach that. We
Okay.
where we see the sun and the moon and the stars are where they are.
Okay, well, bless you. You were pulling my leg for a moment there.
Yes, I didn't want you to get going there. I had to.
Okay. So I'll dial that back down.
But let me take it to when you're done. I do want to take it to here. So, and I'll show you a representation of a macro view of the stars.
Okay. So,
And you could-
all right. So, just give me like 30 more seconds. So, in fact, you can leave that map right up on the screen. One of the tools that people use with astronomy today is those green laser pointers, which are like, you know, it's like 1,000 milliwatts. In other words, 1 watt. But you could actually be standing and you could point to a star, and the beam shows up, and then so the person who's standing next to you is actually looking at the same star. So like you can actually point to stars because the green laser pointer is so powerful. Take a look at a guy who's in South America. He's pointing south. Well, south of South America is Antarctica. And then take a look at a guy in Australia. He's pointing south with his laser pointer. Well, he's pointing to above Antarctica. And they're two divergent, like neither of them is pointing to the south celestial pole in your model.
No, follow the lines of longitude. Follow the lines of longitude, and you'll see that they are.
The lines of longitude, which are curved on that map. Absolutely. You got no argument with me there. But the thing is, if you follow the line of longitude back down south from Africa, and it disappears off the map. That's the edge of the map. You can't go south of Africa.
So
the line disappears. It reappears over there where your mouse is. But that's a little bit of a problem.
We're working with a map that we didn't produce this map. We didn't arrange the continents. We didn't design the latitude and longitude. We did none of that. All we did was discover it and reorient it is all that we did to it. So we don't know for sure whether or not this is a true square or a true rectangle. We've been asking people to join in and help us figure that out. But we do know that a stereographic map does wrap to a sphere and mimic what we've been told by science. Okay, so we know that much. The orientation to it, we are open to correction where it's needed for sure. But our research has shown us that we're on a flat plane, and what I always want to, like anybody that believes that we're on a globe, all I want to do is have them tell me where I can go measure for the curvature and I'll do so, right? Because I know how to use lasers. I know how to use leveling transits. I know how to use GPS stations, all that kind of stuff. So just tell me where you want me to go measure for curvature, whatever your best example is, and I'll go there and I'll measure it.
Okay, that's my wheelhouse. For starters, the planet is really huge, and so curvature.
What's the radius?
Oh gosh, 3,900 miles. I wish you hadn't asked me that. I don't know the numbers off the top of my head.
That's not huge, Charles.
Yeah,
Sorry.
yeah. You just said it was really huge, and I asked you the radius, and you said it was under 4,000 miles. So, how big is it?
Well, the thing is the Earth curvature. If you put whatever the radius of the Earth is, and I should have that memorized, but I don't because I'm not really one of these big regurgitators.
But it's under 4,000, right?
Well, the circumference is approximately 24,900. Let's start there. If the circumference of the Earth is 24,900,
radius R is the important value.
Yeah, but you could derive
establish that, right?
Right.
I got
but the thing is, I don't have these numbers memorized. Okay, a lot of people accuse me of being a regurgitator, and I like my thing is get outside and like measure the angle to the sun on the equinox and things like that. But one of the things I was going to say,
agree that it's under 4,000. It's not more than 4,000 in R, right?
It's whatever it says in Wikipedia. Okay, I said, I don't have these. I don't have the numbers memorized.
Okay, we can move on.
The point that I'm trying to make. You asked me about finding curvature. The point that I'm trying to make is that human beings are extremely small compared to the size of the Earth. In fact, if you were to fly, if you were to have a plane that could fly continuously, like maybe aerial refueling, 500 miles an hour, if you were to fly around the globe, it would take you 50 hours at 500 miles an hour. That is extremely
in which direction?
Okay, it doesn't matter. Any
it
direction.
Doesn't matter. Oh, okay.
Any direction. As long as you are going around,
not with the spin. Against the spin is the same time that it would be. So it wouldn't be 52 days.
The spin of the Earth doesn't matter for air travel. But
yeah, because the atmosphere is glued down, right?
It's with magic Velcro.
Right.
That was good.
There you go. But your question was about curvature. Your question was, where do you find curvature? Are you familiar with Jesse Kozlowski, his channel?
See, now the issue with that, I am. My issue with Jesse Kozlowski is that he's taking into account that the way that they shoot. Jason would be better to answer this question, but the angle, the way that they were shooting, and they were taking perspective into account with their measurements.
They were not. They were just measuring. They weren't taking anything into account. They were just measuring.
And that's my problem.
Okay. The thing is, I don't know if you were talking about his stuff that he did with Soundly, but before he hooked up with Soundly, he has a lot of videos, or I think he might have taken some of the early ones down, where he literally was able to find curvature in like a 10-mile stretch of highway. And then I think he took it down to like a 3-mile stretch. And then finally it was like 1 mile he was able to measure Earth curvature. And it was very, imprecise. The error was pretty high, but he was able to measure that the Earth was in fact curved in literally 1 mile. And more recently, he shot a leveling transit, like you said, Jason, across a lake. It was like a very still pond of water that was almost exactly 1 mile wide. So he set up his tripod like right at the shore, like right at the water, so that the tripod legs were actually in the water. And so he was able to, I guess, put one of those surveying posts or something. I don't know, what's it called? A surveying rod, the ones with the markers on it, so you could see from it.
Story pole.
Okay. He set one of those up next to his transit, and he shot across the lake. And then he did the same thing at the other side with an identical pole. So he had a pole at both ends, and he shot the transit from one side to the other. And he found that level. First off, he put the surveying instrument, like, I don't know, 36 inches off the water or something. It was an exact measure of inches above the water. And what he found was level on the other side was 8 inches higher, meaning the water had dropped 8 inches because he was hitting that pole 8 inches higher than the 36-inch mark. And again, I'm just making up these numbers.
So
Does that make sense?
can you tell us where we can go measure this? Because Ronnie and I will do it.
Well, I'm saying that if you go to Jesse's channel, he describes how he did it, and then you could follow a similar procedure. Find a still, pond, body of water, and take a leveling transit, and then do a surveying rod, stick a surveying rod, in the water, and then you'll find, you could literally see that it has dropped. I mean, you probably can't see the precision of 8 inches, but you will definitely see that, it has dropped.
Okay. Yeah, I know how to use these instruments. I've used them before. I grew up pouring driveways, sidewalks, patios, stuff like that, and we always had to have pitch on them. 1/4 inches,
right, for drainage, or yeah,
1/4 inch per foot drainage.
Yeah,
and so I know exactly what you're talking about. But what we have found is that bodies of water at rest always remain perfectly level. Perfectly level. In fact, that it's actually how they calibrate things like lasers over large distances, because lasers have beam divergence. They're really super inaccurate at distance. So if you want to calibrate a laser, you would use a water level to test to see whether or not it's accurate, right?
Yeah, I don't follow that procedure, because you should be able to. I think you're talking about beam collimation for a laser. Or beam spread.
Divergence. Yeah, divergence. The beam spreads, right?
But you wouldn't need any body of water for that, because what the body of water would help you do is work on the leveling mechanism for the laser, but not the actual laser beam itself. Do you see what I mean?
Well, see, I work with lasers. I'm a drywaller carpenter.
Okay.
I build buildings and stuff, and I can tell you right now, the most expensive equipment that we can find that's practical on the job site for something even nowhere near as far as what people are trying to shoot them for is like 100 meters, $5,000 precise, to be within 1/8 of an inch.
Sure.
And after that, the beam divergence, the spread is inaccurate. It's absolutely impossible to measure. But Jason and I proposed that if we were to go to the shorefront in Galveston, Texas, like the one behind me, and actually set up posts dug into the beach all the way along a 3-mile section, that we could actually, through a long hose and a water pump the water through and mark up on the posts. We theorized that we could build you a 3-mile knee wall, and it would be perfectly level from the ocean with the water level. We would take a guy to come out and shoot and measure. And would you then say that the earth was flat, or would you propose that due to the gravity and the pull to the center of the earth, that you will get the same measurement from the 1st to the 3rd mile? Is that your conclusion?
So the thing is, your water level, and I'm assuming you're having a 3-column water level. So it looks like a capital letter E on its back.
Just one long hose just connected together.
Right. A long hose, 3 miles long, but it's with 3 columns. Do you see what I mean? Because a water level has to have
we could make water level has 2 ends. And
right. It has 2 ends.
Hold it up, and then when the water rests,
but you have to compare. The thing is, if you draw any 2 points, you could draw a straight line between them. You could draw a curve between them. So 2 points is not going to tell you whether or not it's level or not.
Yeah, we could shoot posts all the way along the 3-mile beach.
Well, but here's what I'm going to suggest. Put a T in your hose. I don't know if you think about using a 3 mile
a bubbler, like a go out in the ocean here behind me and put another hose.
Or just a splice. You want a splice?
A splice. But so just picture this: a capital letter E resting on its back, right? So you have 3 verticals, and then you've got a horizontal, which is your hose.
Okay.
And the thing is, there's a video of a guy. I forget the name of the video. It's either called hydrostatic leveling tube or something. And he actually used pond dye. So he had this big black reservoir. So he has this big black line. And unfortunately, the video doesn't show this, but he said, looking through the telescope, he could see. And what he found was the middle column was the water level was higher than a sight line between the end 2 columns. And again, I'll have to send you the link because I don't know the link.
I would propose that would be fraudulent, because we know that any pot smoker knows that his bubbler no matter how many curls or how many different diversions it has, the water level is always the same. Like in a scientist's lab, the beaker, no matter the diameter or the elevation, any of those things, the water level is always the same no matter what happens.
With two ends, and you got no argument with me there. With two ends, what I'm proposing is a water level with a splice in the middle. So you have three columns. Okay, so you have a water level with three columns. You have the end of the hose, the other end of the hose, and then you have a hose in the middle, and all three of those should be at the same level, right?
Well, you agreed that two ends is always level, so that's what we're doing.
Right. Two ends are always level, but if you like point a telescope from one end to the other, you're not going to see anything, because any 2 points, you can connect the line between any 2 points. So if I give you 2 points and I say, you know, this is proving that the Earth is flat, it's like, well, you could draw a straight line between 2 points. There's no argument there.
I see what you're saying.
But if you have a point in the middle,
it's a moot point basically. If we run the test and it's level, it's a moot point, because you could make a circle with a bunch of small straight points.
Right, but if you do this, and like I said, this fellow, I think he had agricultural, irrigation tubing or something. I mean, he had like 3 kilometers of hose. All right. And so what he did is he had 3 vertical columns. It was a water level with a splice in the middle. And then he said it took, they had to pump the thing, they had to charge it full of water, and then they had to wait for like 2 hours while the water levels, not calibrated, while they, what are they called? Stabilized.
Equilibrium.
Right? And then he shot a telescope from one end to the other, and the one in the middle was higher. It appeared to be higher, and that showed the curvature of the Earth.
Well, we know that a telescope isn't going to give us an accurate reading at 3 miles, right?
Well, no, what I'm saying is the telescope was centered at the water level at the near end, aimed at the one at the far end, and the one at the middle was higher. This is very similar to the Alfred Wallace experiment at the Old Bedford Canal.
We'll test it. We'll take it into account, but we're just going to dig 3 posts probably. And
yeah, well, the thing is, now the body of water behind you, I don't know what the tides are there, but if you were able to take 3 posts and put them in a row, and you don't have to do it with like 50, you only need 3.
Yeah, okay? Mark the tide. That's a smart idea.
No, not mark the tide, but like, go out when like low tide or high tide is where the tide changes the least, right? And maybe if you have a buddy and all 3 of you run out the same time, and then stick your post in stick it in the water, and then, put a marker that's exactly, 6 feet above the water, like, use some lumber or something. But the point that I'm trying to make is that if you have 3 posts and they are a good distance apart, I would not do anything less than a couple miles. With the Alfred Wallace, it was a 6 mile from start to end. It was 3 miles to the middle, 3 miles to the far end. And there was a banner, and then there was a target. But if you do it with that body of water, you could do it with 3 posts and have like a big circle or something, but have it exactly above the water, the same distance above the water, and then run a telescope or a P900 or something from the near end to the far end, and you will see the middle post will be higher. You will see the middle post will be higher.
But so I bring into the conversation perspective. And I was showing an image of it. I'll bring it back up. It was a pylon. I don't know if you noticed that when it was up on the screen, Charles.
Yeah. So what we'll do when we run the experiment is we'll have the most accurate leveling transit possible, and we'll bring in the surveyors blind. We won't tell them what we're doing. We'll just pay them to take a level point and bring us a level point 3 miles away. And we want to work within their tolerances. So how many ever waypoints they need to set in between in order to maintain a tolerance of, let's say, a millimeter. Okay.
Yeah.
We'll have them set that amount of waypoints, and we'll have them set their line, and then we'll pull the water level up to it and see if it's true or not. So we don't need to sway the surveyor one way or the other. just project this perfect level for 3 miles. And we don't want to bring in any accounting for curvature or anything, just true level, what a spirit level would tell us.
Right, right. Yeah, well, that sounds like an interesting experiment. The thing that sometimes people fall down with is the experimental design, the actual parameters of the test. Because what I've found is that so many times somebody will have a test and then they'll torpedo their own test because they're either taking something, they're either assuming something or they're taking something for granted. Like the guys who have a spirit level on an airplane and then they fly from New York to Los Angeles and they look at the spirit level and they're surprised when they land in Los Angeles that level is still level in Los Angeles. It's like, yes, that's how they build buildings in Los Angeles, is with a spirit level. And, you can carry one on an airplane.
We believe that the Masonic and Jesuits or whoever it is has put up false tests and evidence.
Sure. But that was a fake, that was a false assumption. The assumption was that if the earth were a globe, the spirit level will change because we're in two different cities,
Well, a gyroscope should. A gyroscope should. But the problem with that is when the gyroscope runs out of energy, it tends to tilt. And therefore, if you have one that can perpetually run, which I think a few flat earthers have tried, but it's still up for debate. But really, we could switch the conversation just quickly to perspective. And then I think Jason wanted to ask you some questions about irrational things with pi. Jason, this is just really quick. I see a person standing at position 1, Charles.
Yes. Yeah, so I'm familiar with this concept. I think this is where we had our conversation a long time ago. I'm very familiar with this concept and how this sort of explains.
But you agree this is a moot point, whether flat or ball. This is how it is observed.
Well, what I would agree is that if the Earth were flat, this diagram perfectly explains why things disappear bottom first.
Thank you.
And okay, perfectly explains it.
I rest my case.
If the Earth were flat, yes.
Boo! God bless you.
I'm just giving away the store here.
God bless you for being honest, Charles.
Now, here's what I would say. If you could put that diagram back up.
Oh, you want me to? You just said it was right, so.
I just said it was right.
It explains perspective on a flat Earth.
Right. So take a look at position, or take a look at the little red line that says 1.
Okay. Up top.
Yes. And here's the problem with this diagram is the blue ray that goes down left and the blue ray that goes down right. Those are actually 180 degrees in real life. Okay. So you don't look down to the left and you don't look down to the right. So that's the problem with this diagram, is that in the real world, like you could use a surveying instrument.
Yeah. I was just using it for the plain observation that you won't be able to see sections 0 through 4 until you're within that circle.
Right. Absolutely. But here's the problem. If you were in that green circle, that green region, you're not going to see zone 4 by looking up. You're going to see zone 4 by looking horizontally.
You're right in front of you. Right? But there's no curvature. And this does explain how boats sail over the horizon. And this is an actual image of the CN Tower where I'm from.
Okay.
Perfectly explaining.
You're from the CN Tower?
Toronto. Hey, and what's funny, my name is Ron, and it's actually in the word Toronto too. Can you believe that?
Wow. So you are from the CN Tower. That's awesome.
Yeah, man. And it is the most absolutely perfect flat earth, buildings being missing proof. It absolutely explains why 6 floors of the TD building right there is missing, because you are outside of the circle of view or sight that floor and observation above the ground is. This is how I believe the flat earth is. And I believe we're at a moot point where you can come at me with star evidence, but we can show you this evidence. And I believe if anything, we're at a moot point. And if we can't find that water could bend, or that we're going to have to concede that the earth is flat and the Bible is true.
Oh, I believe the Bible is true. There's no argument there. It's just a question of how literally you take every single story. Like my classic is on the Sermon on the Mount. So
Charles, I take every word like it was absolutely spoken out of the mouth of God.
Well, but hear me out, because I think you might appreciate this example. Jesus said, and I'm paraphrasing, take the beam out of your own eye before you criticize the splinter, in your neighbor's eye. And did he really think that there was somebody walking around with a 2x4 sticking out of his eye socket, or was he speaking metaphorically? It's a wonderful bit of wisdom. But were there people walking around with planks of wood sticking out of their face, criticizing a splinter, or was it a metaphorical? Do you see what I'm saying?
I know what you're saying. I have a question for you.
Oh,
though.
Sure.
Just a simple question. What do you think the great deception is? If you found the creator through the Bible, which you said you have done, and the Bible speaks about the great deception that would happen in the end days, what do you think that great deception would be?
That's a great question, and I really don't have an answer to it. I mean, I would love to answer it, but I don't have an answer. I do believe that when they say the end days, that those days may not be like close at hand. Like the end days might be at 1,000 years away or 2,000 years away, or maybe it's 100 years away. Maybe it's a decade away.
Well, they say that a day with God is 1,000 years on earth. So if he did everything in 6 days and rested on the seventh, Charles, we can actually document that it's been roughly 6,000 years.
Yeah. Well, I'm going to have to agree to disagree on that point. Yeah. So the age of the earth, I think there's a lot of evidence for things being a lot older, 4.5 billion years.
But how old's the oldest tree? I know it. It's called Methuselah.
I think the oldest tree that as far as on record that I've seen is like 2,000 years, if I'm not mistaken.
Yeah, it dates back to the chronological time that the flood would have taken place.
Right. But that's a tree. We're talking about like mountains. Like, if you go to the Grand Canyon and you count the layers.
Another great one. The fact that all the sediment layers on all the mountains on Earth have a distributed deliverance of seashells and clams.
Yes.
Even to the top of the peak of Mount Everest, proving that it was once covered by water.
Or proving that it was formerly below water, And
it rose.
Right. So
isn't that amazing?
But the thing is that I've studied geology at the university level, and plate tectonics is a fascinating,
There's a good one. Subject. So could it be that the Earth is scripturally said to shake and move on its pillars? So the tectonic plates could actually be a magnetic type of an action that free energy is covered, and those pillars could be the things that shake and move. So they're not actually tectonics. What we're really speaking of is the pillars of the Earth.
I'm curious. You brought up your education. How many degrees and where do your degrees come from?
Oh, so I have a Bachelor of Science from Penn State in science, and I have a Master's in Science from Drexel University.
What university?
Drexel. It's in Philadelphia. It's an engineering. It was primarily an engineering school in Philadelphia, but they've since expanded out.
Gotcha.
So, but degrees don't mean anything. Like
the Bible,
I'd be the last person to claim that makes me an expert on anything.
Like a doctor, they have to swear an oath, right? You didn't have to.
Hopefully, the Hippocratic oath, yes.
So that's the problem. But if you have, Charles,
I'm sorry.
That was good. If you have, you can just ask for forgiveness. But anyways, continue. Sorry.
Oh no, I missed what you said there.
Anyone who swore an oath, we all come to Christ and he forgives us all if we ask for forgiveness, right?
Yes.
That's the truth.
Yes.
No matter who you are or what you've done or anything like that.
Yes. Yeah, I believe that. And I believe that it's a personal struggle.
But we're not to swear. We're not to swear any oaths. That's
not swear an oath. The thing is, you could play with the language, swearing versus swearing an oath, like I don't use profanity, so people call that swearing. But then if you put your hand and you say, I swear to tell the truth, then that's,
That's serious, right?
So yeah.
It's binding, right?
Yeah. I mean, the thing is within your own conscience, I mean, people lie all the time and they'll say, I swear to tell the truth. And then they'll lie. So, there's no.
But if you work on it, really, go ahead, Jay.
Yeah.
Well, there is evidence that that oaths are binding from lifetime to lifetime. Actually, it's an interesting topic, but I mean, we've sort of covered a bunch of, you know, Earth is flat, stuff like that. What about math?
Go to the math. You can screen share. Jay.
Okay.
Do you want to talk about math at all?
Oh, absolutely. And if you want to talk about pi and how pi is a rational number, absolutely. I got a great
Amen.
that I think you've probably never considered. But
well, I would love to hear it actually.
yes.
Mine is, well, actually, let me start with a question. I just want to hear your answer. How many numbers would you say are irrational?
Well, there's an infinite number of irrational numbers.
Woo! Thank you. Thank you. Would you say that there's more irrational numbers than rational numbers?
Wow, that's a great question. The thing is, if the answer is infinity for both, you know, you can't really say one's more than the other. Like if there is an infinite number of rational numbers and an infinite number of irrational numbers, can you say that one group that's infinitely large is bigger than the other group that's infinitely large? Do you see what I'm saying? It's almost like a philosophical question.
It is philosophical. I mean, that's where we're going with this. I mean, I don't want to argue about 2 + 2 = 5 and stuff like that. I want to go into the philosophy of numbers.
Okay.
And so can you explain to the audience what it means to be irrational in terms that they would understand?
The definition of being irrational is that you cannot write it as a fraction. You can't write it as a fraction as a whole number in the numerator and a whole number in the denominator. And that's really the simplest thing. So if I say 3/7, you know, 3/7 is a rational number. Rational means ratio. So 3/7, it's a whole number, meaning I can count to 3 on my fingers. I can count to 7 on my fingers. Hopefully I can count to 14 on my fingers and toes, but you know, you get the idea. Using a counting number, which goes to infinity, you know, in the numerator, and a counting number in the denominator, that's a rational number. And anything that doesn't fit into that, you know, that category is irrational.
So would you say that it's possible for an irrational number to exist in reality?
Yes, because interestingly enough, if you take the ratio of a circumference of a circle to the diameter, you get an irrational number, even though you started with a ratio. But the circumference of the circle, there's nothing to say that has to be a counting number. You know, so even if you have a circle and like, let's say you're cutting it out of wood or steel and you have it be a 2-foot radius, you know, or a 4-foot diameter, right? Well, the circumference is not going to be a rational number. The circumference is going to be 4 times pi, you know, 12 point something. So
what would happen if any computer tried to calculate any rational number? What would happen?
Well, I'm sorry, I don't understand the question. Can you rephrase it?
What would happen if any computer in this world tried to process an irrational number? How long would it take for it to calculate it?
Well, the question is on precision. And so and you're a builder, so you know that, you know, if you measure, you know, a 2x4 to the nearest 1/4 inch, well, that's really sloppy carpentry. You don't want a nearest 1/4 inch. You want the nearest 1/16th, you know, if you're going to be, you know, joining stuff. And so, but then the precision, you don't cut things to the nearest 128th of an inch. I mean, that's, you know, the equipment doesn't exist in the carpentry world. You know, maybe a laser cutting a piece of steel might be able to do that. But then even then the laser, you know, you can't cut it to the 1/10,000th of an inch, you know? So the precision is what we're talking about. If you have an irrational number and you express it as a decimal, the decimals just keep going and they never repeat. There's no pattern, but you know, in the real world, we have limits to our precision.
Would you agree that pi is in no way special and that every single irrational number is exactly the same, where if any computer were to try to ever process it, it would instantly fry the computer because it could never get to the end of the number forever, right?
Well, it wouldn't fry the computer. The thing is, the instructions you give the computer are to, hey, I want you to calculate the digits of pi. And then computers do that. You know, that's one of the tests of computing power is how many digits of pi can you compute? And it's been computed out to the, billionth digit.
That's backwards. We think
but every single irrational number, and you've already admitted that it's a really large amount of numbers.
Well, an infinite number of digits without pattern, without repeating. Yes.
But there's an infinite amount of irrational numbers.
Yes.
And so what are the only buildable numbers that we can use in reality?
Well, it depends on what you mean by buildable. The thing is, if you express, like, for example, you could make a piece of steel that's pi feet long, approximate, or actually, you wouldn't be able to calculate it exactly because you'd run out of precision, but you could say, all right, this piece of steel is a little bit longer than 3 feet long. In fact, it's about 3 1/10 feet long. In fact, it's like 3 1400ths feet long. Do you see what I'm saying? So it's like you could make this piece of steel, and if you increase the precision, it's 1/100th of an inch, it's 1,000th of an inch, it's 10,000th of an inch, then you could sort of simulate pi.
What's the end?
You're going to run into the limits of precision of how you can measure that.
Simulate, but the fact that it's been cut off at some certain point, because we know pi goes on to infinity, it never stops.
Right.
The fact that it's been cut off has resulted in what? It's become I'm going to lead you into this. It starts with an F.
I'm not really sure what you're getting at. The thing is, you say cut off.
Fraction. It's become a fraction, right?
Oh, right. So if you say 3.14, which is what a lot of kids use for pi, in fact, instructions say, oh, just use 3.14 for pi. That's a really good approximation. And 3.14 is a rational number. So yes, that is a fraction. It's
3.14 without the decimals, right?
Or 3.14 or 3 1400ths. That's a rational number. That's a fraction. Yes,
it's a fraction. So yes. I'm going to take this conversation to the point where I am going to assert that any number that cannot be contrived through geometry is nothing but imaginary and has no reality whatsoever. So all irrational numbers, all negative numbers, 0, all of those things are non-real, and that they are magician's tricks, and that the only numbers that are real are whole numbers and fractions. Do you have any argument against that?
A huge argument, because the thing is, it presupposes that only something that could be measured with a tape measure or something. I mean, that's not what you said, but I'm sort of paraphrasing. If you can't stretch a tape measure out to this value, then that value doesn't exist. And so, let's just take negative numbers, for example. And you could say, we've got a certain level, let's call it like the first floor of a building, and then you have the parking garage. And so it's like, all right, how many feet up do you go? Okay, so I'm going to go up 10 feet. I'm going to go up 20 feet. And then you may say, well, how many feet do you go up to get to the parking garage? Well, you go up -10 feet, or you go up -20 feet. I mean, that seems ridiculous. You say, well, you go down 10 feet, you go down 20 feet. But if you were forced to say, how far do you go up? You would have to use a negative number. And of course, negative numbers exist in the terms of finance. If you owe somebody money, you owe somebody $10. How much money do you have? Negative $10.
You're talking about numbers in reference to a baseline. You're not talking about numbers to something that exists in reality, because I'm a carpenter. So
sure.
My example is if I'm going to build a house and I need 1,000 2x4s, I can add 2x4s, I can subtract 2x4s, but I can never have negative 2x4s. That would be bringing into account something that does not exist. So, I mean, this argument actually goes back to the arguments that were being had in ancient Greece. This was Democritus or whatever, the Democrats, versus I think it started with a P. And so this is an ancient argument about whether or not something that exists or doesn't exist can be counted as something as real. And Ronnie and I we're not going to back down for this argument that anything that does not exist, if you bring it into any formula, it's a logic error. Anything that's impossible, anything that does not exist, you result in a logic error. In fact, the older calculators, when you were to divide anything by 0, it would say right on the screen, error. I don't know if it still does that anymore. Yeah. But you can't divide something by something that does not exist.
Well, no. You can't divide by 0. You could divide by every other number, but you can't divide by 0. I mean, you can even divide by an irrational number.
Because it doesn't exist, right?
Well, no. The thing is, no, I'm not going to say it doesn't exist. I'm going to say dividing by 0 doesn't exist. It's undefined, meaning the rules of mathematics has not defined the operation of dividing by 0.
Well, see, you know what
undefined.
You know what I found, Charles, and I'm not the best with math, but I found that when a mathematician sets up a giant, extremely competitive and difficult equation, the way that he seems to always figure it out or get through the equation seems to be by canceling and making things nothing. And for me, I've wondered,
balanced equations that result in 0, right?
Right.
Like a cheat code, right? That's what I've noticed. Non-math.
Yeah. Well, you used a really important word, and that was cancel. And I tell my students that cancel is not a mathematical operation. Cancel is simply a verbal shorthand that people who work with math, teachers, students, mathematicians, it's a verbal shorthand that we can use to communicate. So if
it's not real, it's metaphorical.
Well, no. But it's like the operations are add, subtract, multiply, divide, take the square root, cube something. There's all sorts of mathematical operations.
Yep. Cancel
is not one of the mathematical operations. Cancel is what we call things. Like, for example, if you were to say, what's 1/2 times 2/5, right? 1/2 times 2/5. Well, you have a 2 in the bottom, 1/2, and you have a 2 in the top, 2/5. Well, those 2's cancel out. The answer is 1/5, right? The 2's cancel out. But there's no mathematical operation that says cancel. So what actually happened? You divided the numerator and the denominator by 2. Right? So that's the technical thing that happened. You divided the numerator by 2, you divided the denominator by 2. That is legal. And so what'd you do with your pen? Your pen, you canceled them out. You just drew a line through them. Okay. But yes, that happens in the movies. Like if you watch a mathematician movie, there's going to be canceling going on because it's very visual.
Will you concede the point that that Pythagoras has nothing but a theorem that cannot be proven?
No. I will absolutely not concede that point. The Pythagorean theorem has been proven. I think I saw a website where it was like 117 different proofs of the Pythagorean theorem, some of which were algebraic, some of which were geometric, where they literally just slid around pieces. They, cut them and slid them around. And then some of them actually use calculus and advanced math. There's a bunch of proofs of the Pythagorean theorem.
Have you ever done the proof for the Pythagorean theorem with a square sides 1?
We'll see.
Yes. Absolutely.
I propose a challenge that when Jason gets his YouTube channel back after the 21st, he's got more subscribers than me, that you and him and Jason's going to get the materials and the compass and the square. And we're going to do what we're about to discuss here. Let's do it live. I'll make a promo piece for it. We'll get it promoted. Let's really see if this is true. You guys continue the conversation. I'm sorry to interrupt.
Yeah. Well, no, but here's the thing. It depends on the limits of the precision of what you're dealing with. I think, Jason, you had on your channel, it was like 2 years ago, where you cut pieces of angle iron in 2 foot, a 3 foot, and a 3 foot, a 4 foot, and a 5 foot piece of angle iron. Sure. And then you lined them up. And I think you had, right, either you started with the right angle or you started with the triangle, but you found the ends to not match up by like a 1/16 of an inch. And you said, well, this disproves the Pythagorean theorem. And I would argue it shows that there's limits to precision of cutting and measuring steel. It does not disprove the theorem.
Well, there are ways to disprove it.
I'd be very interested to see it.
Well, Jason, I was going to ask you, what about the discussion that we have about subtracting? Because I know as a builder, Charles, I use 3, 4, 5.
Okay.
I build buildings, and when I want to square walls, I measure 3, 4, 5, and I snap chalk lines through them, and I can enlarge that But Jason, what happens when I try to scale that down?
Well, that's the thing. The question is the Pythagorean theorem, Charles, is it scalable? Can we
Yes.
scale that?
Yes, and you can use any numbers. In fact, you can use 3 irrational numbers for the 3 sides of the triangle. You'll still get a right angle.
So I just want you to try something out yourself. With the 3, 4, 5, I want to go 50% scale. So take each one of the sides down 50%. So the 3 to 1.5,
Sure.
the 4 to 2, and the 5 to 2.5.
Yes, and you could square them.
Square them, and then tell me what happens.
It works perfectly.
No, it doesn't. I can show you this right now, and I know you'll understand this. I don't even need to break out the calculator except for the final calculation. You can pull it up.
All right. I normally have a piece of paper in front of me. So let me just so you have 3, 4, 5.
Yeah.
You have 1.5, 2, and then 2.5. So 1.5 squared is
3.
No, 1.5 squared is not 3. 1.5 times 1.5. What you did is you multiplied by 2. We're squaring. 1.5 times 1.5 is what? 2.25? Right? I don't have I think it's 2.25. 2.25. And then 2 squared is 4 because 2 times 2 is 4. And that 2.5 times 2.5 is 6.25. Right? If you have 25 quarters, it's $6.25, right? That's one way of remembering that. If you have 25 quarters, $6.25. Does that make sense? So here you have 1.5 squared plus 2.5. I'm sorry, 1.5 squared plus 2 squared equals 2.5 squared because 2.25 plus 4 equals 6.25. So it's perfectly scalable.
All right. I may concede that I made a mistake there.
Okay, fair enough.
Good. That was interesting. But we could still do the test, or does that now throw the test off if you're marking it in a different place?
Well, no, the thing that I did is I did the squaring the circle in geometry, where
which is impossible. It's impossible to square the circle. I mean, you could draw a circle inside of a square. You could draw a square inside of a circle, but you can't get the numbers to match up with whole numbers. That's impossible.
Well, when you do the a squared plus b squared equals c squared, when you do the actual geometry, it does not match. Have you ever noticed that?
Well, no. The thing is, if you're talking about a square, like the diagonal of a square is an irrational number. If you have a whole number, of the length of the square, I mean, you can call it 1 foot. If we have a 1 foot by 1 foot square, and then you measure the diagonal, it's going to be the square root of 2. Which is an irrational number. You cannot physically measure that on a tape measure. I mean, you can approximate it on a tape measure.
But when you do the actual geometry.
No, it works out perfectly.
Yeah, you got to swing the arcs, right?
Yeah, when you swing the arcs, when you draw the square based on geometry, when you figure out everything by geometry, that's what Soundly, he created a video saying I was a liar, and all he did was take a clip where I reset my compass on my scale because I was being super accurate. I didn't want anyone to say, "Oh no, you didn't have it just right." I reset it, and he was saying that I was being inaccurate, but it wasn't. It was off. You don't get the result that you expect through the calculator, through the decimal system.
Well, I'd be okay. Now you got to be careful. If you say with the decimal system will approximate if you're dealing with something that has like an irrational number. The decimal system gives you an approximation. It's
observably off. We're not talking about hair whisk.
Well, okay. So one of the things I remember from, again, this is a video you did 2 years ago where you were using either SketchUp or you were using a geometer's tool. You were using some digital tool that allowed you to draw circles and stuff. And the thing that a lot of programmers use as shortcuts is they use polygons because, technically a circle doesn't exist in the mind of the computer. Every time we see a circle, it's actually a polygon with a really large number of sides. And so this program, I noticed that when you zoomed in, it was visibly polygonal. Yeah. It was like a 20-sided polygon. I mean, you would draw in a circle.
You can see the straight lines created.
You could see the straight lines. And this is, like I said, this is a video you did 2 years ago. So I don't know if you remember what I'm talking about, but you were talking about how,
I remember.
you know, like you were like, well, look, it doesn't line up. And I was yelling at my computer screen. It's like, of course it doesn't line up. It's a polygon. It's not a circle, you know, because the programmers who wrote that program, they just used a polygon to approximate it. And so therefore the pixels didn't, you know, they weren't perfectly
But when measuring stuff with the AE map to debunk the rise and sets of the stars and the sun and the moon, it definitely works still, the polygonal circle where the equator and the tropics would be, right, when we measure.
Well, no, I wouldn't say a polygonal circle. No, just use a regular circle. And the AE map, you know, works fine as a clock. You know, works fine as if you want to measure north-south distances. Doesn't work to measure, you know, angles of anything.
Yeah. Okay, we got that. But yeah, but about the math, so that's interesting. So I don't know if you guys came to a conclusion on that, but
well, one of the things I was going to tell you about pi is that the reason why it's 3.1415927 something is because we have a base 10. I'm going to do this isn't a Masonic symbol. We have 10 fingers. We have 10 fingers. And so that's why we have a base 10 number system. There's nothing that says that we have to have a base 10 number system.
But we don't have 10 digits, do we?
Well, no, we do have. I mean, in the base 10 number system, we have 10 digits, 0 through 9.
Yeah,
0 through 9. So 0 is counted as a number in the decimal system, right?
Right. It's counted as a number, and it is also and when I say a digit, it's a symbol. We have 10 unique symbols.
But you do realize that
numbers 0 through 9.
You do realize that 0 is undefined.
No, it's not defined. It's perfectly defined. The only thing that's undefined is dividing by 0. But 0 has a very, very specific definition.
What?
Yeah,
how many things don't exist? Tell me.
How many things don't exist? It's uncountable.
Whoa! Come on!
Unicorns. How many unicorns are there? 0.
Well, we
you
can't
just told me it was defined. How many things don't exist? Come on.
How many things don't exist? It's uncountable.
Yes, exactly. So
like unicorns don't exist. You know, hippies riding unicorns.
Well, we could debate whether pink unicorns existed.
Pink unicorns don't exist. Pink farting unicorns don't exist. You know, farting unicorns with leprechauns don't exist. You know,
zero is a non-existing thing.
No, 0. You know, like if you want to talk about the real world, you say, you know, I gave away all my jelly beans. How many jelly beans do I have? I have 0 jelly beans. So that's a real world example of a, you know, but 0, you know, on the theoretical level, it's like we take the number line and it's the halfway point between -5 and +5, you know, or it's the average. It's the mathematical average.
It's completely undefined. So
it's not undefined.
To place it on a number line between a positive point going off into infinity 1 and to place it between a negative point going off into infinity -1, it's completely undefined, and it has no place in the number line whatsoever because it's undefined.
No, it's and that might be a misunderstanding, but 0 is defined. Dividing by 0 is undefined. You know, like for example, you know, you were talking about lumber. You have I have 1,000 2x4s. You know, I can count my 2x4s. Well, what if you get done building all your houses and you used up all your 2x4s? I'm going to ask you, how many 2x4s do you have? And you would have to say, I have 0 2x4s. Like that is a practical example of using the number 0 in a very real sense. It's defined. How many 2x4s do you have? I have 0 2x4s.
I can never say I have -2.
Well, no,
ever, because that's
negative
exist.
Numbers. That's another argument, and we could talk about
non-reality right there.
Okay, but we're talking about the number 0. You said the number 0 is undefined, and I wanted to correct you.
It is.
But if you gave away all your 2x4s, you built all your houses, and you have no more 2x4s, and I say, give me a number. How many 2x4s do you have? You wouldn't say, I have no idea. It's undefined.
None.
You would say 0.
You're talking about a reference point or a benchmark, and I'm fine with the use of 0 in a number system if everybody understands that it refers to the fact that we have nothing. But to use it as a placeholder in a decimal system the way we do leads to an infinite amount of errors.
No, I think that's where, I think you're getting confused with like the dividing by 0. Because for example, let's take the 2x4 example. Let's say you have 20 2x4s and you're going to do a project that requires, 25 2x4s, right? And you're committed to do the project. You're going to do this project. It requires 25. You literally have 20 in your room. You could say that you have -5 2x4s. I mean, obviously you don't. You have 20 in the room. We see them there.
Yeah,
but you're committed to do this project, which means you're going to have to buy some more, right?
It's a theoretical standpoint that we know has a non-reality to it.
But you could do the same thing with finances. When people are in the red.
I know. Finances is the worst. Come on.
Right.
I mean, it's a debt-based monetary system, right?
Well, only if you go into debt. There's no rule that says you have to go into debt.
Isn't how much debt you can accumulate is how wealthy you are nowadays, right?
Yeah, all the money that we have came from debt, so none of it's real, right?
Well, so I have a next question.
Yes,
I have a question for Charles to ponder. I don't know if you're a coder, if you know how to do scripts with the internet. I don't myself. I only know like the bare minimums. But Jason had proposed to me an idea that our computers are working off of binary coding, right? 1s and 0s.
Yes.
Off and ons. So Jason was theorizing that if we used images instead of numbers, or some type of why don't you explain it a little bit, Jason? This might be a great answer to get from Charles.
Okay.
Well, I consider binary to be the least inefficient way of data transfer possible. Would you agree?
Would you say least inefficient?
Least efficient.
Least efficient. Yeah.
Yes.
Yeah. Well, you could go less than binary, because you could just introduce noise, which then needs to be filtered out. But yeah, I get your point. 0s and 1s, you can't just.
It's Morse code, right?
You're right. Well, yeah, right. Morse code. Morse code is like a step up because you have dots, dashes, and you have spaces. So you have actually 3 things that you can deal with. You get that?
So it's tertiary. So binary is really like
I get your point.
The most inefficient way we could possibly process data, right?
Yes. If you're just talking about how many symbols do we have to work with, binary only has 2 symbols, a 0 and a 1. I get your point. Yes.
Yeah. So the point is if people actually wanted to have a breakthrough in technology, that the Roman numeral system is probably the most efficient means that we could do things, if only we were to expand the symbols for every placeholder as we grew. Would you agree that?
Well, the thing is, I grew up in the 80s, or I grew up in the 70s and 80s, and so I remember when the end credits of the movies, it would say copyright, and it was always a Roman numeral. Yeah. And then the numbers in the 1980 whatever, 1990 whatever, it was MCM Mexella was it was like the date was just the year was like 10 characters long. So I would disagree with you that that the Roman numeral system is an efficient way. I think it's very inefficient.
What if we had a placeholder for every single tens, hundreds, thousands?
They do have placeholders for all those, and they actually have placeholders for half of those. They have a placeholder, not only a placeholder for 10, but one for 5. They have one for 100, but they also have one for 50. So they've gotten a little bit more efficient than just 1, 10, 100.
But then if you were to go millions, billions, trillions,
right? But the thing is, you require one question of efficiency is how many characters do you need to express a number? So like I was saying before, if you have the number 1985, all right, the year I graduated from high school, the number 1985 in Roman numerals is many characters long, but the number 1985 in the decimal number system is 4 characters long. Does that make sense?
It does, but
Roman numeral system is less efficient.
Mm-hmm. Well, only in certain places, because if you were to actually write those, if you were actually to do the binary for those numbers.
Oh, it's more efficient than binary.
Yes, that's what we're talking.
Less efficient than decimal.
That's what we're talking about right now.
Okay,
It's binary.
It's more efficient than binary, less efficient than our decimal system, base 10 system.
Yeah, but can you see how, if we're to use a graphics card and we were to have an interface that projected an image, and that image had a symbol on it, and then there was a receiver that when it saw that image, it picked that up, that we could actually graphically, through the use of symbols, reduce the amount of digits that we're using, or bits or bytes, by an infinite amount, and that it would, the binary is the absolute worst way we could possibly process data.
Well, yeah, that's the problem that you're going to get into. I get what you're saying about like the image, and you could talk about, say, the Chinese alphabet, or
Yeah.
the whatever the cuneiform is, or I don't know the language, what it's called, but the characters in the traditional Chinese, language, there's tons and tons and tons of them, because each character represents actually concepts, and there's combining of concepts. So I get what you mean when you say using a symbol may be more efficient. So it's like with one Chinese character, that one Chinese character may represent the word complex,
Right.
COMPLEX. It's a 7-letter word, and they represented it with one letter in the Chinese, but then the problem is you have to be able to recognize these characters. What happens if you turn the character upside down, et cetera, et cetera. But the thing is, if all you're going to do is compare to binary, yes, just about everything else is going to be more efficient than binary. There's one problem, and that is transistors are either on or off. Okay. And so a computer chip is made of, billions of transistors, which are either have states, either on or off. The magnetic coating on magnetic tape, it's either magnetized plus or magnetized minus. So you have just a regular magnetic tape can be binary as well.
But you could have that. You could have that on-off state linked to a graphical image, and then that symbol right there.
When you combine them, like if you had several binary digits. But the thing is, that's what they've done with computer technology. They've got 8 bits make a byte.
Yeah,
and then 8 bits make a byte, and then so what is that? That's a number.
And all that.
That's a number between 0 and 255, right? So you have 256 possible characters that can come from a series of 8 little switches, each switch being on or off.
But
Does that make sense?
Yeah, the use of a graphics card and doing this optically with images would probably reduce the amount of data that we have to process almost infinitely by the amount that we expand the.
No, because the thing is, there will be a limit to your images. Like, for example, how many images are we talking about?
Yeah, resolution is going to be a limit.
And the problem I foresee is that you're going to have to encode and decode. So, if you do video editing, there's all these different encoders to make the video as small as possible, but also as clear. Same thing with photography. You've got MPEG, you've got JPEG, you have a JPEG 4, you have GIF or GIF. And so it's like, these are different ways of encoding images. But if you got rid of the zeros and ones and made it exclusively symbols, you're going to have a huge amount of problems of encoding and decoding. Plus, it's like you're going to have to save up an alphabet of these images. And so what I would say is, if you have the zeros and ones, being that computers are so fast, they don't care that they're talking in zeros and ones. I mean, we humans can kind of translate the zeros and ones to letters of the alphabet, like ASCII. And now they've got Unicode, which is a 2-byte language, or a 2-byte character set, 256 times 256, right? You've got a huge amount of characters now, not just the alphabet and numbers and symbols. So the thing is, the computers are so fast that they don't care that it's ones and zeros. They do it in the blink of an eye.
Could you imagine if every one of those processes was just looking at an image, a symbol, and then it was through RAM, it was understanding what was encoded in that, and wouldn't that launch the processing power exponentially?
No, because you have to encode and decode those symbols. You know, each of those symbols that you're talking about has a meaning. You know,
Yeah,
what is
but
that meaning? And then can you do math with it? You know, can you multiply by a picture of an apple? You know, and then what does that mean? You know, what happens when you have apple times banana? You know, you have the combination for a smoothie, you know, but like, what does that mean in the computer's memory? So, I get your point that if you used symbols, you would sort of increase the vocabulary,
oh
but
yeah,
the vocabulary of zeros and ones gives you infinite capability,
but
because
like
anything can be coded with zeros and ones, whereas everything can't be coded with a picture of an apple or a picture of a banana. Do you see what I mean?
what one picture, one image, one graphic can represent it, and there's no need for all the ones and zeros that it would take to do it in binary.
Right, but here's the thing: is that if you have that picture of the apple and you translate it to ones and zeros, well, you know, like that's the depth of your image. That's the depth of the information that is stored. In fact, there was this thing that they were doing a couple of years ago where kids were sending secret messages, and they were just JPEGs. And the thing is, a JPEG is a compressed image. It's not a loss-free image. The JPEG, you know, data is not. It's not one piece of data for every pixel on the screen. It's a lot smaller than that. So because there's compression involved, you could play with how you do the compression. And so they actually hidden encoded messages, and it was just a picture of, say, an apple. It's like, I'm going to email you a picture of an apple, but you've got this special software where, yeah, you see the apple, but then you see, you know, oh, Johnny's, you know, kissing Susie behind the schoolyard. But so I get what you mean by the images have a huge amount of depth compared to binary. But what I want you to understand is that if you start with binary, you can create the images, and you could go and you could do anything with them. You can go, you know, as far as you want. It's just a matter of how many ones and zeros you have.
Yeah, I just want to bring across the point that it's the most inefficient way we could possibly do it.
Yeah, right. In terms of numbers of symbols, yes, it's very inefficient. But the thing is, it's the natural language of silicon. It's the natural language of the transistors that are making up our computers. And the thing is that they are expanding in this, like there's like gel computing, and there's quantum computing, and there's different stuff with biological tissues. Like, for example, human DNA has, you know, four different letters. So it's like, it's a base 4, you know, code, you know, it's more efficient than binary. But the thing is, computers naturally speak in binary. You know, they're very comfortable with binary. And also computers are very, very fast.
For it to change. I mean, we're in 2018 now. Come on.
Well, but the thing is, you're familiar with Moore's law, right?
Yeah, I've heard about a bunch of these laws. There's the first law of thermodynamics, and second, which I've both debunked. So
no, you have not done either.
What other laws do we want to talk about right now?
Well, no. What I was talking about was Moore's law, which is not a law. It's a rule of thumb based on history.
Yeah.
And that is that computing technology doubles roughly every 18 months. And of course, it's not a law. How could that be a law? Because
I think I don't agree quite with that, because I think they've been dripping the technology out for profit. Like, I believe, like, you know, in the 70s and 80s, they could have had Skype, you know. I think they've been super dripping it out. I'm not saying imagine what the government
Well, here's the thing. Anytime I hear about a conspiracy that says that, you know, there's this advanced technology that they're not letting us have.
No, see, I wasn't stating that. I was stating
no. Right. You said dripping it out, but I get that. But the question I always have is about the technology producing industry versus the technology using industry. So let's take batteries. Like, as people always say batteries, you know, like the AA battery. Oh, you know, it runs out of juice so fast, and we have to buy more, and it's just a big scam. Well, how many companies make AA batteries? Okay, let's say it's less than 10 in the world, right? How many applications are there for using AA batteries? Tens of thousands, right? Tens of thousands, like, you know, childhood toys and, you know, used to be Walkmans, but now we have, you know, MP3 players, but, you know, all sorts of personal devices, personal electronics, you know, stuff that you want to take to the beach and you want battery power, you know, the little portable speakers, all sorts of devices. portable GPS you want to take in the hiking in the mountains. Okay, they all take batteries, and let's say they all take AA batteries. So now we have a 10,000 to 1 ratio of makers to users. The logic isn't there that they would drip that out.
My question is, let's take it here. So I did hear Jason bring up the law of thermodynamics, and I'd like to know, Charles, do you believe or accept that there might be an application where there has something been built that could run perpetually forever, an over unity system?
A perpetual motion machine? No, I do not believe that is possible.
So you don't believe we can reach over unity?
And then the thing, well, I'm not sure about that language. I'm not really familiar with that language, but I know that in any system, like there are always going to be forces. There's always going to be friction. There's always going to be something that's going to mess things up.
So that's a no? No.
Yeah.
Okay,
definitely no.
Thank you.
So I've got a question for you.
Yes.
All right. So compressed air. We've been dealing with this jet fuel hoax
Oh
thing.
my goodness. Okay.
Right.
I'm sorry. I interrupted. Yes, go ahead.
Compressed air. So when you compress air, it produces heat, correct?
Yes, I believe that's how it works. Yes. And then when you release it, you feel cold.
Yeah. What is it that happens when you release compressed air?
Well, you feel cold. Like if it's through a nozzle, you'll feel.
So you can
cold.
freeze an ice rink with it, right?
Well, the thing is the compressors that power refrigeration equipment uses, a little nozzle. I mean, it's got, tubes of refrigerant, but in there is a little nozzle. So they compress it, and then they release it through the little nozzle, and then that's where the temperature drop comes from. But it's being heated on the other side. I mean, it's so you like, a standard air conditioner, it's hot. You feel the coils on the outside, or even a refrigerator. The refrigerator feels warm in the back because that's where I guess they call them condenser coils are, whereas the refrigerant coils are inside the refrigerator. And
the coax and condenser.
But like, like if you plug in a refrigerator, I mean, the joke goes, you plug in a refrigerator and then you open the door to cool off the room, but the actual thing that would happen is you'll warm the room up because it's an inefficient process,
So I want you to consider my air compressor. It's a little 2-gallon air compressor.
Okay.
I use it for, nailing guns and stuff like that. So I can plug it in and the motor will run. It's using, energy to compress the air. It produces heat. Now it's stored that compressed air. I can unplug it, and as long as there's not a leak, I can let it sit there for days, weeks, whatever it takes.
Right.
It's become ambient temperature. And then when I go to release that air, it will actually create cooling.
Yes.
So the rules of thermodynamics suggest that work produces heat. And you would argue the point that as that air is being released, that it's producing work because it's moving air all around, right? It's pushing air, it's blowing air, but at the same time, it's not producing heat. It's actually creating a cooling effect the entire time.
I think you're confusing work in a practical sense, operating a nail gun.
Well, maybe
work in the physics sense.
So are we going to an implosion? Is this more of an implosion type of a discussion?
No, the thing is, I think you're going into a lower energy state. And again, thermodynamics is not my area of expertise, so I'm literally just spitballing this stuff.
Yeah.
But my understanding of that situation, which is a great situation, you've got this room temperature body of compressed air, and then you start operating your nail gun, and then you find the temperature is dropping in this, because the air is being released. But what I would say is that the reason why the temperature is dropping, it's not breaking a law of thermodynamics. You're probably going into a lower energy state, compressed air versus uncompressed air. And again,
it's doing work, but it actually operates in the opposite fashion as to what the law of thermodynamics would demand.
But can you tell me that the work it's doing to operate that nail gun is more than the work, or say the negative work that is accomplishing inside the compressor when it releases that air. Because I would argue that work is being done on both sides, but that on one side, then the work might be negative.
Consider a can of compressed air that you would use to dust your keyboard.
Right.
All right. So all the work's been done. The compressed air has been put into the canister. There's no work happening, no work happening, no work happening. Then you go to spray off your keyboard. Now it's doing work and it's cooling. It actually cools off. So the releasing of compressed air actually completely goes against the laws of thermodynamics.
No, because I what I'm trying to say to you is that I don't think you're understanding what's happening in the compressor. You're talking about like what it's doing, like, you know, blowing dust particles. Yes, you're doing work. You're blowing dust particles. You know, I guess the definition of work is force applied over a distance or something.
Yeah, that's what a can of compressed air does.
Right. But what I'm saying to you is in the physics sense, what is happening inside that can? And if you say nothing, well, then your understanding is incomplete, because something is happening inside that can. You're taking air that is under higher pressure and you're transferring it to air that is under lower pressure. So something is clearly happening in that can. And what I would argue is that it does involve the concept of work, but in the negative. In the negative?
How would you argue that point? That's what I'm curious.
Because the temperature is going down.
Yeah, it breaks the law. It breaks the laws of thermodynamics.
It's not breaking the laws of thermodynamics. And this is really gets back to a lot of like the flat earth debate, which I find to be a matter of misunderstandings, you know, honest misunderstandings a lot of the times. Now, I'll be honest with you, Jason, I'm not a thermodynamics guy. And this is literally the first time I'm hearing of this situation. I'm familiar with, you know, canned compressed air. I'm familiar with that, but I'm not familiar with the argument that it is breaking the laws of thermodynamics. So I'm going to have to table this conversation and do my homework.
I'm just doing.
That's a great answer, actually. Sorry, Jason. Go ahead.
Great answer. I just want to bring it up that the laws that we have been told so often are not laws. They're actually lies from scientists, which I equate with being Satanists. And you know, that's if you follow our channel, you know the position that we stand in. And
we do believe that, right?
I'm not trying to bust your chops too much, but I'm trying to make a point that we're lied to about a lot of stuff.
Well, even just not that long ago, it was discovered that the theory of the speed of light was fudged, and that it was the scientists that were trying to agree together, and they actually agreed on a different speed or measurement. It was Rupert Sheldrake who did the research on that. I don't know if you're familiar with that. So basically, if the law of speed of light can change, you know, everything should be out on the table. We just want to discuss things with you, Charles.
Oh, sure.
Because you're a super intelligent guy, and now to know that you're a Christian is like super. I'm like super thankful. Praise God. But I think tonight's been a great hangout and a great call. I don't know what else you guys would like to go over. Any questions from the chat, but I think this has been like super edifying. I don't know about you guys.
Well, it's always nice to like hash out these ideas, because, you know, there's some very big ideas. And yes, you know, you and I don't see eye to eye on the shape of the earth, but it's like it's a fun discussion, and we get into some theoretical stuff, you know, irrational numbers and like the laws of thermodynamics, and you know, so it's just a fun discussion, even if we're disagreeing on some, you know, some issues. So
yeah, totally.
I'm really enjoying it.
It's brain expanding, right?
Yes.
I love it. Thank you for coming.
And we are getting trolled. We're getting trolled as we speak too, because.
But if I could just say, like, and you said something about the jet fuel hoax. Are you familiar with like the not Pinewood Derby, but the CO2? I guess they call them CO2 racers. They do it in high school physics, where you have it's essentially like a Pinewood Derby, like you do in Cub Scouts, but there's a CO2 cartridge that you fit in the back of a little car that you carve out of balsa wood. Do you know what I'm talking about? A CO2 racer?
No.
I've never heard of that. Are you talking like a street race?
No. You know, like the little, I guess they power whippets, you know, a little CO2 cartridge, like for,
Oh, sure.
you know,
Yeah.
so it's a standard cartridge. It's like, you know, 9.5 grams of CO2
Oh yeah,
in there, you know?
Whippets.
Right. Whippets. Right. But not the nitrous oxide, the CO2. And
Okay.
so it's a compressed, you know, you could buy them by the case. It's just compressed CO2. And there's a physics demonstration that allows kids to sort of, you know, build their own little cars. And there's a little receptacle on the back of the car, like a little hollowed out cylinder. And you slide the CO2 cartridge in there. And then there's a little starting gate, and the starting gate has pins that puncture the CO2. So you have two cars side by side, you hit the button, and then it's like a mousetrap, bam, and it punctures the CO2 cartridges, and these two cars go zooming down the track, and it's a lot of fun. And you measure the velocity, and you measure the, you know, obviously you see who's got the fastest car, and you measure the acceleration. It's a physics thing. But the point I'm trying to make is that little bit of CO2 can only propel a balsa wood car like 20 or 30 feet. And so what people are proposing is that they compress air to power, you know, a 747 that's going to go across the Pacific for a 12-hour flight, that you'd have enough compressed air, you know, and you know what compressed air
suggested that?
You know,
that's just crazy.
Yeah.
We're not
The jet fuel hoax is what I was talking about.
we're not in that camp. See, Jason was the guy that started the jet fuel hoax, and that was like the COINTEL. Remember in the beginning of the call, I told you there's people out here that supplant actually really bad information.
Okay.
What you just brought up was the actual, I guess you want to say, block guard for the truth that it's actually compression and perpetual motion technology. It has nothing to do with compressors. It's the way that the vortex of the fan spinning creates a sucking force, which is actually propelling these machines without using fuel. It has nothing to do with the compressors. But Jason, you're the one who really broke it.
So the big problem with the reason why I got on the bandwagon with the whole jet fuel hoax is if you look up something like the Airbus A380,
right, and
it's going to tell you that it carries 85,000 gallons of fuel.
Right.
All right. So they do say that fuel does not weigh, like the A1 jet fuel does not weigh the same as water, a little bit less.
Slightly less.
Yeah, I think they bring it in at like 6.8 pounds per gallon.
Yeah, it's still heavy, but you know, it's like 90% of water or something, but it's heavy, but it's slightly lighter than water, but still it's heavy. But here's the thing.
So
go ahead.
Planes, there are channels that have actually, there's books, like you can get the coffee table book of the A380, right?
Right.
You get the coffee table book and you look at where the fuel tanks are and what all the schematics for it are. And there is no belly tank on the A380, according to its own coffee table book.
Okay. So it's all on the wings? Are they exclusively wing tanks?
Exclusively wing.
Okay.
The two main wings and then the two rear ailerons.
Oh, really? The rear ailerons are fuel tanks. Okay.
Fuel tanks.
I did not know that.
Carrying 85,000 gallons. Now, if you multiply that times 6.8, you're going to come up with a tremendous number.
Oh, meaning the weight of the fuel on takeoff. Yes, absolutely.
Okay. But then if you look at the structure of the plane, you're going to see that the wings are 100% cantilevered, right? That there is nothing, there are no ties that are holding the wings up. It's 100% cantilevered, and I'm a builder, and so I put the challenge out to anybody to through engineering, true engineering, show me what size I-beams that you would need. The wings stretch out 125 feet from the fuselage. So that's fully cantilevered. Show me what size I-beam that you would need to be able to carry half of the weight of 85,000 gallons. And structurally, you're not going to find any sort of metal in any configuration in a 100% cantilever that's going to be capable of doing that. So
When you say cantilever, you mean, a horizontal beam that does not have, vertical supports, like the marquee of a theater. There's no columns holding up the marquee. It's cantilevered out over the sidewalk. That's what you mean by cantilever. Just like a wing is clearly not being supported underneath it. It's a very long beam that's carrying a load. Is that what you mean by cantilevered?
Correct. Yeah.
Okay.
125 feet. The wing, the engines, two of them on each side we're told weigh 6,000 pounds each.
Sure.
Plus the weight of the fuel. And so I'd like to
it's called the wing spar, if I'm not mistaken. The main load bearing thing of a wing.
Yeah, I'd like to see somebody with an engineering degree show me what size I-beam would be necessary to carry that load.
Yeah, so let me see. Wings, is it a wing spar? Yeah, I think it's a wing. It's called a wing spar. The thing is, and there's all sorts of schematics. I mean, I just did a quick Google search for wing spar, and I'm getting all these schematics.
You see how it's tied back?
But the structure is quite complex. It's not like it's a single I-beam. It's a whole bunch of beams all tied together. But the thing is, the guys who are doing the structural engineering, I mean, you could take that apart and you can actually get the schematics for what size wing spar or girders they're using, and it does line up. I think one of the problems, though. Oh, that's great. That's a great picture.
Yeah, you see this picture, Charles? This is going to blow your mind, because one of the flat earthers actually is not a flat earther. He was a jet fuel hoaxer. And he showed this, and I believe this observation deck.
Yes.
This is an absolute speculation, but I think it was 4 times lighter than the amount of fuel in the wings, and the absolute monstrosity of a.
Right. That's not even cantilevered because it's partially suspended.
The cables.
You've got cables and you've got beams. Yeah. Well, but here's the thing about the fuel in any jet aircraft is you're not having that weight of fuel at 125 foot distance. Because I think that's probably where the misunderstanding is coming in, is that somebody took some calculator and they said, I've got 125,000 pounds of fuel, and the wings are 100 feet long, right?
I think
all that weight isn't at the end of the wing.
250,000 pounds of fuel.
Oh, okay. So I'm confusing the length of the wing. 125 foot wing, and then so many pounds. But do you see what I'm saying? You have to take the pounds of the inner tank, and then the pounds of the next tank, and then the pounds of the next tank. And I think if you do that analysis, then the structure comes up perfectly fine.
No, we've actually shown that you can download a 3D schematic, a 3D model of the A380, like in the SketchUp, and you can measure anywhere you want on the model.
Okay.
And so the thickness of the wings, given the concept that there are no mechanics in these wings.
I mean, other than the flaps, right?
No, you would have to totally alleviate the idea that there are mechanics and flaps if you were just go total volume of the wings.
Oh, okay, just the total volume, meaning like pretending it's an empty shell and you just fill it with fuel. I get you.
Yeah, you still don't have room for it.
Yeah, that's one of the conspiracies that I have just sort of dismissed out of hand. I haven't actually looked into the numbers, but I think it would be fascinating to, because the thing is, one of the reasons why I'm in this debate is because I learned so much. I've learned so much about the sun, the moon, the stars. I've learned about the geometry of the earth. I mean, like, that's why I participate. One of the reasons why I participate. And so this will give me an opportunity to learn about aircraft design. So I'm looking forward to Oh,
it's
tackling that.
It is full of absolute deception. They have videos of people crawling through the wings like it's some sort of fuel tank,
Well,
inspection?
no, I mean, and it's usually painted green because it's the anti-corrosion coating. But yeah, you can, some aircraft, I think in the Spruce Goose, I think you could actually stand up in the fuel tanks, in the wing.
Wow.
You could stand up in the fuel tank in the wing.
And would there be any signs of fuel residue in the tank?
Well,
The ones that we've seen, they didn't have any, right?
None.
It's an amazing thing. So, but Charles, you do understand what we're saying is that they invented, or they basically figured out, I believe it was a German scientist, Jason, if you could remember his name, was it Victor
Schomburger, yeah,
Schomburger? So
implosion technology. That's a great question. You're a science guy, Charles.
Yes.
Did you know that hydrogen implodes and does not explode?
I I would have to disagree with that, but I mean, if you're at a quantum level, something weird may happen. But
you can observe the implosion.
Yeah.
You fill up a balloon. It's pretty basic.
Have you ever watched a hydrogen implosion, like in a science class?
Okay, so I think I know what you're saying. Implosion. If you have a hydrogen balloon, and let's say you make it even ridiculous, like you have a hydrogen and oxygen balloon, so it's got a perfect mix. And when you ignite it, right? When you ignite it, it will produce water. I mean, it'll produce water vapor. But I think I get where the implosion thing may come from is the
it doesn't explode.
Convert it to water.
No, it doesn't go out. It's not an explosion. It doesn't go like this. It goes like this. It implodes. That is the force of burning hydrogen. It implodes, and that's completely contrary to everything that's taught by science.
I can give you guys a demonstration if you hold tight for 1 sec. Check this out.
Sure.
Check this out.
It's actually filled with 100% hydrogen.
Okay.
And it's surrounded by about
You guys hear it?
40% oxygen in the atmosphere.
Yeah, but notice he said 100% hydrogen, which
I know.
means
Wait, this
inefficient.
is the beginning of it. This isn't the money shot.
Bring it up to the balloon, burst the balloon.
So that was an explosion, right?
Whoa. Okay.
Well, because it was using the room air. It actually wasn't an explosion at all. It was actually a deflagration.
So now you want to check. He's going to switch it. Here, pay attention.
Okay.
It gets better. We're going to step it up from that.
Okay.
Okay, that was just hydrogen mixing with the oxygen
Should
in the
I say
air.
my goodbye?
This is an HHL
Okay.
bubbler.
All right.
Fine, I'm here. It's okay. So we're going to mix now the oxygen with the hydrogen all in one balloon.
Oh, okay.
Okay, and that's what I have in this guy.
All right. That balloon looks larger.
Well,
Slightly larger.
It's larger because here's what we have to do. I'm going to make a bunch of bubbles in this tray of soapy water.
Okay.
This is a bubbler that's making hydrogen through electrolysis. Everybody knows on our channel, Charles, just so you're with us.
Right.
So basically, you're going to
Those
see,
bubbles right off the
and
top.
we're talking about whether an explosion or an implosion is going to happen here. And I'd like everyone to keep in mind, explosions cause injury. I want to point that
Many
out.
as you can, leave the water behind.
Okay.
And
I'm
then we'll just
leading,
add a little
Charles.
flame
I'm
to
leading.
it.
Oh, all right. So you're gonna blow me up in theory.
Now, this could be a little bit louder than the previous balloon, so why don't you go ahead and put the earmuffs on right now.
Oh, you were just
We'll get
making
ready
me
for
look
it.
all kinds of beautiful this morning. Okay.
Now, I'm sure you can still hear me. Now, in order to pick up the bubbles, you're going to have to get your hands wet.
Okay.
So dip your hands down in the soapy
You've
water.
told me to take off my rings already.
All the way up to about right there.
Okay.
Perfect.
So now what?
So now go ahead and
Make
take your
bubbles?
hands out.
Okay.
I'm going to make some bubbles in here, and these bubbles are filled with a mixture of hydrogen and oxygen.
Probably
gas.
mostly
All right.
hydrogen.
We're going to see what happens
No, it's
If we
2
add
parts
a little-
hydrogen, 1 part oxygen.
Oh, yeah, that's right. Thank you.
while
Thank
they're in
you.
the palm of your hands.
Alrighty.
So what I want you to do here in just a second is scoop up as many of those bubbles as you can. Just skim them off the top.
I'm getting nervous.
Leave the water behind.
So what you're going to see is an implosion take
Perfect.
place here.
Yeah,
I'm
that's
going to
nice.
lead people.
Okay, extend your hands out in front of you. Put your hands
And this
flat.
is power.
And for
you
everybody else
later.
in the studio, you might want to plug your ears because in 3, 2, 1.
Boom!
You okay? Yeah. That was you had a lot of bubbles there. That was and you know, the cool thing about that, you're okay, right? Show your
Yeah, I'm
hands.
good.
Did not hurt.
I'm
Nope,
alive.
nope. Okay, dry your hands off. The cool thing about that is that reaction happens so quickly.
So basically what we're stating is that reaction is an implosion, and it's not an explosion. And Jason, you can take it from there.
Oh, just that all the things that we're told by science are lies. The laws of thermodynamics, all that are misdirects by Satanists, and that implosion technology is actually the technology of the future. HHO, all of that we are being milked right now by a satanic system.
So here's what I would ask you: the demonstration with the bubbles in that lady's hands. So clearly the bubbles disappeared instantly. You know, probably in less than a frame on the YouTube video.
Mm-hmm.
So the visual you may see, I see a bunch of foam bubbles. All of a sudden, I don't see a bunch of foam. You know, it just disappeared. So you can kind of see, you can kind of imagine that it's getting smaller. So here's the question for you: if you put those bubbles in a container, like an oatmeal container, like, you know, just a paper lid, and then you stuck a little match in the side, would the lid pop off? Would the lid pop off, or would the thing crush down?
See, that's a faulty line of questioning. I got to call you out on that.
Okay.
The lid does pop off when the bubbler implodes. You can
call that an explosion?
No, it's an implosion, and you can measure it with a syringe. What you do is you hook a syringe up to the bubbler line, and you cause the implosion to take place, and it sucks the syringe in, completely proving the fact that it's imploding.
No, what would suck the syringe in is the fact that it's converting, it's making water, and at room temperature, water is liquid, which takes a lot less room. But the actual reaction, which produces steam in an instant, right, is an explosion. It's extremely exothermic.
No, it's not an explosion. We can watch the slow motion footage of balloons, HHO balloons being popped in the same fashion in slow-mo footage. I've got the videos up.
Okay.
And you can watch that there is no explosion. The balloon does not blow out whatsoever. The balloon, when the match goes to the balloon or the sparker goes to the balloon does what it always does, and it does its shrink up, and that the gases do not emanate out whatsoever. They stay there. And there's a lot of other tests that show that hydrogen, when it's combusted, creates a vacuum, and that it's actually vacuum technology or that's being used, or vortex technology. And that is the type of technology that's being used in airplanes as well right now.
Yeah, I would have to say I've not seen any evidence for that. I mean,
well, we can show you.
Here's a question for you. Here's a question for you. Do you know what I did in the military? I mean, I was in the Marine Corps Reserves. I was only in peacetime. I never served in combat. Never, but do you know what I did? Because this is gonna kill you. I'm telling you.
It's gonna kill me. It's gonna kill me.
All right. Just take a guess as to what I did.
You refueled planes.
I refueled planes.
No. Okay. I want to submit to the argument right now. We believe the technology is less than maybe a decade old.
Okay.
So how long ago did you work in the military?
Okay. So you got me there. I was 85 to 95.
Okay. They were probably still using I think this breakthrough just came out. That was hilarious. I got another question for you. Really quick. Do you know anything about what was discovered by Alton Harp with the quasar problem?
No, I do not. Not familiar.
So what had happened was there was a quasar that Alton Harp found. Maybe we should watch it. Let's watch it really quick, because we got you're the guy for astronomy. Now this is Robertson Genius.
But I know next to nothing about quasars.
Oh, you don't?
Yeah, I don't know anything about quasars.
Maybe I shouldn't go there.
Yeah, I'd just be spitballing it if you showed this to me. So
well, what happened was Alton Harp discovered that a quasar was actually local, and what science tells us is that quasars are on the furthest reach, right? The red ones are on the furthest reach of the. This is an absolute joke, that model. I can't believe I had that in there. Forgive me. I should edit that out, eh? But so the quasars were at such a distance, and they didn't work out on the plot chart. But when Alton Harp actually plotted them in locally where he thought that he was seeing the quasar in the sky, he basically debunked the fact that the Big Bang Theory has everything stretching out at an equal proportion, moving away from the initial blast of the Big Bang. But what Alton Harp did was he completely debunked it, because puts the redshift completely out of context and destroys the theory. I am going to be on a podcast called The Non Sequitur, and this is going to be something that I'm hoping Red's Rhetoric is there, because he's the one that I called out. This video is back from 2015. So it's been a few years. It's been 3 years since I called him out. And this quasar issue is a huge problem for the Big Bang cosmology. It completely debunks it. And no figure, Alton Harp was disbarred, kicked out of the science, lost his position. Everything was scrubbed, just like science to do, right? But I guess it's out of your realm. And the other thing too, if you're a guy who believes in evolution, my question for you is basically this number here. I'm going to play a clip of it. Let's see if you have an answer for this.
But eccentric theory.
It's right here.
But then, quite unexpectedly, a completely new law of nature was discovered. And our universe relied on this law being so precisely tuned that it seemed no rational theory would ever explain it.
Our universe seems to be defined by a set of numbers which in some sense look special. If we had different numbers, we would end up with a sterile universe. People react to this seeming coincidence in a number of ways. You could say it's the outcome of some kind of design or providence. We could say it's a brute fact we have to accept, because these numbers might be determined by some theory which we haven't yet discovered.
For a while it was possible to believe that the laws of nature were not so precisely set as to require the hand of a creator. But then a completely new fundamental property of the universe was discovered. An anti-gravity force present in space itself. It is called the cosmological constant, and when cosmologists calculated its effect on the evolution of the universe, they realized it had to be very finely tuned indeed.
The fine-tunings, how fine-tuned are they? Most of them are 1% sort of things. In other words, if a thing is 1% different, everything gets bad. And a physicist could say, maybe those are just luck. On the other hand, this cosmological constant is tuned to 1 part and 10 to the 120, 100.
I just want to pause it there. Do you know what the cosmological constant is, Charles?
I've heard of it, but again, this is, cosmology is not my wheelhouse. So
okay, I'll keep it playing.
120 decimal places. Nobody thinks that's accidental.
Because if you even knew 1 iota of how fallacious your words are, when you speak of no God or I don't know God exists, that makes God very, very sad to think that you don't know that he exists. Do you know that?
Red, why did you upset him so much, Red? God damn.
Poor fucking baby. Well, I'll tell you what, if he does exist, tell him to grow the fuck up. Why does he care about my opinion, my position? And in fact, I would say he should be sad for me. He should be sad for you, Roy, because you are failing to meet the burden of proof.
On the other hand, this cosmological constant is tuned to 1 part and 10 to the 120, 120 decimal places. On the other hand, this cosmological constant is tuned to 1 part and 10 to the 120, 120 decimal places. Nobody thinks that's accidental. That is not a reasonable idea, that something is tuned to 120 decimal places just by accident. That's the most extreme example of fine-tuning.
No force in the history of cosmology has ever been discovered to be that finely tuned. The cosmological constant needs to be set to 1 part in a trillion, 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 trillion. Otherwise the universe would be so drastically different that it would be impossible for us to evolve.
So, that's what I propose to any atheist, anyone that, uses math to quantify life, the symbiotic relationship for the calculations that control our Earth and reality that we observe from the stars, from all the atoms that we can actually count and theoretically measure, results in this astronomically impossible number with trillions and trillions and trillions of decimal places. Just to be, if it was off 1 trillionth of a percent off, everything in this reality would cease to exist. And absolutely no theoretical person with a brain in their mind. I know Charles has accepted the Lord Savior into his heart, which absolutely was the best thing that came out of today's hangout. But I don't think there's one atheist that could debate the fact that the fine-tuning of our reality, and this is why Jason and I both propose that we live in a Christian simulation. Charles, you might find that interesting. And we trolled NASA when we were at a convention during the eclipse in this little town in Missouri, and we asked the astronaut. I said to him, "I'm sorry, sir, but I'd like to tell you that I do believe that we live on a flat Earth." And I said, "I do believe we live in a simulation." And you know what he said to me, Charles? He said, "Actually, you can't prove that you're not in a simulation." So he agreed with us, and the cosmonautical constant is one of the reasons why I do.
He did not agree with you. He said you can't prove that we're not in a simulation. So in that sense, he was correct. You know what I say is that, like, people get on me all the time about proof. Prove this, prove that, and I can't stand the word proof outside of mathematics. You can prove lots of stuff in mathematics. You can't prove anything in science.
But we've already talked about how mathematics is nothing but a magician's trick, right?
Well,
there's so many different factors in the mathematics that we have right now that are being used in absolutely satanic ways, that all the irrational numbers, single one of them is purely theoretical and don't exist in reality, and all the formulas that we use are baseless, correct?
No, I disagree with 100% of what you just said. The thing is, with the mathematics or, magician's trick, you could perform magic because the person you're performing it for doesn't know the trick. As soon as the person knows the trick, it's no longer magic. It's just a trick.
Yeah, we're exposing the magic. That's what we're going to do. That's what we do.
But I disagree that math is magic.
It is.
May seem magical if you don't understand the workings. Just like a trick, you go to a trick and you have a camera over behind the magician, so you could see the guy loading the rabbit into the hat. When everyone's misdirected, you could see the guy literally put the rabbit in the hat.
The trick in mathematics is using things that don't exist.
Well, yeah, but you say they don't exist, including things like negative numbers and zero, and I say that they do exist. It's just you might not be able to count 2x4s.
Yeah.
But anyway, the point that I was trying to make.
Just a second, you cannot create an irrational number in any way, shape, or form. It's purely a mental concept.
But you can. The circumference of a circle. If you create a circle that has a whole number diameter,
that's geometry.
An irrational number.
No, geometry.
So there's a real world example of creating an irrational number. If you have a square,
that's rasterizing. So whenever you do something in like Photoshop, things like that, you do a true circle, everything's rasterized because it's not possible to do it with numbers. The decimal system is a complete fail, and it's an Indian trick. They are the snake charmers, and they gave us the decimal system, and it's a bunch of BS, and we need a new mathematical system. The whole thing needs to be scrapped and started over with.
Well, the thing is, mathematics is just a tool, So it's like, you're a builder, you've got a whole ton of tools, and you probably have some tools that are really important to your work, and you probably have some other tools that maybe they're kind of getting rusty, and so it's like they're good tools, they're bad tools, they're tools that like you probably weren't using laser levels 20 years ago because they didn't exist, and now you use them every day. So it's like they're just tools. They're just tools. A laser level is not magic. It just is a tool that helps you do your work. And the same thing with mathematics. It's just a tool. It can be abused.
Yeah, it can be abused. I'm glad you admitted that.
Yeah. I mean, the whole traveling salesman problem.
Because
the missing dollar.
Anytime you introduce anything into any formula that doesn't have an existence, you create a logic error, and you're going to be able to create a formula that's going to have a zeroed out effect, and it's going to look logical, but the mathematical trick is introducing the thing that does not exist like it does exist, and it's done all the time.
That's what we've found, Charles. And like I said, tonight's been great.
Yeah.
I don't think we should just like. I think we should end it on a good note. But go
okay,
ahead.
so to want to end on the good note, then here's the point I was trying to make before we had that segue, is that you can't prove that we're not in a simulation. Okay, no one can, because whatever you say is the proof could be simulated. It's part of the simulation. This proof, you know. In fact, there's this great concept called last Thursdayism. Are you guys familiar with last Thursdayism?
No.
Last Thursdayism, and it's a thought experiment. And it's it's a silly, but I mean it's a silly concept, but it's a fun one to think about.
Okay.
And the concept is that the universe was created last Thursday. Okay. And so you say, well, no, of course not, because I could remember, what I did 2 weeks ago. No, those were implanted memories. And you know when they were implanted? They were implanted last Thursday. It's like, yeah, but I got this newspaper from last year. No, that newspaper was created last Thursday with a year ago's date. I mean, it's like any evidence you got, the Grand Canyon, any evidence you could come up with, the response is that evidence was created last Thursday, including your implanted memories. And so you can't prove that the universe wasn't created last Thursday. There literally is no way to disprove it. So my thought about simulation is that, first off, I don't believe we're in a simulation. But if we are in a simulation, it's a heliocentric one.
Okay, no. You're allowed to have that belief, but we've gone out and measured and tested, and we're going to stand on the fact that water always finds its level. But do it almost sounds like you might be familiar with solipsism. Do you know what that is? That is
I forget. Tell me.
Well, solipsism is the idea that the only person that could ever conceive consciousness is yourself, and nobody could debunk that you're not the only consciousness in reality. So it kind of speaks to what you're stating, but what we believe in is a little different, and we think we can use the Holy Scriptures with our arguments and debates.
I think there's a lot of wisdom in there, but yeah, I mean, I think you and I and Jason, we all agree, I think more than we disagree. So this is a very good conversation.
It was great. Thank you.
All right.
Yeah. So thank you
so much for the invitation.
Yeah, I'm gonna play us out with a video, but hang out for a minute after Charles. Just
okay.
I'd like to talk to you off air a little bit too.
Yeah. So I'll mute myself and then we'll rejoin after we're off air.
Yeah.
Thank you.
Thanks to the chat. Thank you, everyone.
Yeah, I'm just gonna say a quick thank you, Father in heaven, that we glorify your name tonight and that we came together for this amazing call, and bless everyone involved, everyone on the other side of the screen, and especially Charles for standing up for his beliefs. Amen. I'm going to play us out with a video.
You are now tuned into the one and only
All Out Truth Channel. The true Yahawashai Network. Please turn your volume to max. And be prepared for
Awake Souls and Event Skeptic.
Back again with yet another outstanding debunk video. Broadcasting worldwide. We go beyond the lies and deception. Soar to the highest of heights, down to the darkest of deceptions. Nothing can stop.
Ladies and gentlemen, let's get ready to rumble!
best community for top news and information regarding simulation reality, Christianity, and flat Earth proof. Now reached the first ever simulation nation realization. We are beyond flat Earth.
TKO!